good experience on electrical machine too. He is also electrical machine too in our
Streaming start.
electrical department. And this parallel operation of alternators is a very essential topic in electrical machines. We have already known that grid is synchronization with the electrical machines like alternators, and how the machines behave with the grid, where the machine is connected with the grid. So different aspects that in alternators there are two continuous, one is excitation energy governing system. Two controllers, we find the power two controllers and governing system and excitation system. So when machine is connected with the behavior of the machines, before connecting with the grid and after connecting with the grid, it is different. The alternator is the load condition and the alternator on load condition. There are different things. So suppose the behavior of the machines depends upon the load. Which type of load is connected with the grid? Whether active load or reactive load, or both active load and reactive load. And in my experience when I was in the field, so the instruction from the Central Electricity Authority, the alternator has to connect with the grid in such a way that the alternator has to dance as per the grid need. That means you cannot put any constant on the alternators, any parameter. You cannot put any on the alternator, but the alternator should dance as per the grid requirements. That means when there is a frequency fall and frequency rise, accordingly the alternator should provide active power or reduce active power. Similarly, in case of the requirement of the reactive power, so alternator automatically we provide the reactive power or reduce the reactive power as per the requirements of the grid. And you know that in the power station, in the basic alternators, so there are certain limitations. The alternator machines cannot dance as per the grid because machine is designed for particular mechanical stress. There is vibrations. अपन देखिए पावर हाउस में जो मशीन को इंस्टॉल कराई से इंस्टॉलेशन में देखिए जितेबाला आपनकर वाइब्रेट मैक्सिमम वाइब्रेशन लिमिट पर इंस्टॉलेशन कराई आपन जो फ्रीक्वेंसी जितेबाला सपोज हाई है सपोज फ्रीक्वेंसी जितेबाला हाई है आपन सेतेबाला इनपुट को कमिया पड़ो फ्रीक्वेंसी आपन इनपुट कमिया पड़ो सपोज आपनकर अधिक लोड अछि आपन से इनपुट अधिक देथिबे इनपुट जो अधिक देथिबे सडनली लोड चेंज हो जो लोड जीरो हो जो इनपुट आपनकर सडनली रिड्यूस हो परिबो इट विल टेक सम टाइम से तमरे जो वाइब्रेशन ता हो से वाइब्रेशन ले आपनकर जो फाउंडेशन ता आपनकर डैमेज होवा चांस से सेठी कोन करे जाय फील्ड रे आपनकर गोटे डेडबैंड गोटे जाय आपनकर गोटे आपन कोनते जे आपन गोटे प्रोटेक्टिव डिवाइस यूज करंती ओवर फ्रीक्वेंसी माने अंडर फ्रीक्वेंसी और ओवर फ्रीक्वेंसी पहिले एस्टिंग फ्रीक्वेंसी से अधिक होले आपन मशीन ग्रिड रो डिस्कनेक्टेड हे जो यदि फ्रीक्वेंसी जो ମାନେ କମି ଯଦି ଗୋଟେ ସର୍ଟନ୍ ଲିମିଟ୍ ଯଦି କମିବ ଡିସ୍କନେକ୍ଟ ହେଇଯିବ ଏବଂ ଏଭବ ହେଲେ ମଧ୍ୟ ଡିସ୍କନେକ୍ଟ ହେଇଯିବ। ସେମିତି ମଧ୍ୟ ଭୋଲ୍ଟେଜ୍ କେସ୍ରେ ଓଭର ଭୋଲ୍ଟେଜ୍ ଅଣ୍ଡର ଭୋଲ୍ଟେଜ୍ ରିଲେ ପ୍ରୋଟେକ୍ସନ୍ସ ଦିଆଯାଏ। କାହିଁକିନା ଆପଣଙ୍କର ମେସିନ୍ସଟାକୁ ଆପଣ ଗ୍ରିଡ୍ର ରିକ୍ୱାରମେଣ୍ଟ ଅନୁସାରେ ଡ୍ୟାନ୍ସ କରିବାକୁ ହେଲେ ଆକର୍ଡ଼ିଂଲି ମଧ୍ୟ ମେସିନ୍ଟାକୁ ଡିଜାଇନ୍ କରିବାକୁ ପଡ଼ିବ। ତା ଷ୍ଟାବିଲିଟି ମଧ୍ୟ ଏନ୍ସୋର୍ କରିବାକୁ ପଡ଼ିବ। ନହେଲେ ଆପଣ ଗ୍ରିଡ୍ ଚାହୁଁଛି 47 ହର୍ଜରେ ଗ୍ରିଡ୍ର ହେଇଗଲା 47 ହର୍ଜ, ଆପଣ ମେସିନ୍ ମଧ୍ୟ କନେକ୍ଟେଡ୍ ହେଇକି ରହିବ। ମେସିନ୍ ସେଫ୍ଟି ଦୃଷ୍ଟିରୁ କ'ଣ କରାଯାଏ, ସେଠି ଗୋଟେ ଡେଡ୍ ବେଡ୍ ପକାଯାଏ, ସେଇ ବ୍ୟାଣ୍ଡ ଭିତରେ ହିଁ ମେସିନ୍ ଅପରେଟ୍ କରିବ। ସେଇ ଏଭବ୍ ବିଲୋ ରେଞ୍ଜକୁ ଗଲେ ମେସିନ୍ କ'ଣ କରିବ ନା ଆଉଟ୍ ହେଇଯିବ। ତେଣୁକି ଆଜିକାଲି ଆମର ଯେଉଁ କଣ୍ଟ୍ରୋଲ ଗୁଡ଼ାକ ସବୁ ୟୁଜ୍ କରାହେଉଛି ପାୱାର ହାଉସ୍ରେ, ଦେଖିବେ ଆପଣଙ୍କର ଅଟୋମେଟିକ୍ ଭୋଲ୍ଟେଜ୍ ରେଗୁଲେଟର୍ ଆଉ ଗୋଟେ ହେଲା ଗଭର୍ଣ୍ଣିଂ ସିଷ୍ଟମ୍। Both are responsible for at no load condition to control the frequency. The governing system is responsible for control the frequency at no load condition. And automatic voltage regulator (AVR) nowadays that is called the DVR, digital voltage regulator, nowadays used in the power house. That DVR at no load condition control the voltage. And load condition that control the reactive power. Once the grid set अपन खरे कनेक्ट हो गले पावर कॉन्सेप्ट आसीगला। करंट टर्म आसला माने वोल्टेज आपन बाहर अछि, करंट आसले पावर टर्म आसीगला एवं रिएक्टिव पावर से कंट्रोल करो। नो लोड कंडीशन ले आपन तो नो लोड इज नॉट कनेक्टेड। आपन ऑटोमेटिक वोल्टेज रेगुलेटर एवीआर कोन डीवीआर कोन से कोन कंट्रोल करो, खाली वोल्टेज कंट्रोल करो। अपन एक्साइटेशन करंट रिएक्टिव अपन कंट्रोल करिवे, वोल्टेज कंट्रोल करिवे। सिमिलरली फ्रीक्वेंसी लोड कंडीशन इलेक्ट्रिक एक्टिव पावर कंट्रोल। ए पैरेलल ऑपरेशन दैट इज वेरी इंपोर्टेंट, इज वेरी इंपोर्टेंट टॉपिक। जेटा कि आपन को जदी सडन चेंज इन लोड, सडन चेंज इन वोल्टेज जदी हला ताले कोन व्हाट इज द इफेक्ट ऑन द जनरेटर और व्हाट इज द बिहेवियर ऑफ द जनरेटर। So here I don't want to take more time. Our faculty, Pawan Kumar, he will take this section. Please enjoy this topic.
A very warm good morning to all. I welcome you all the faculty members of different affiliated institutions under BPUT and my colleagues and our head of the department, CUPGS BPUT Roorkela, Professor Maneswaran Naik sir. Thank you for giving me this opportunity, and I am a regular scholar at NIT Roorkela, about to submit my thesis in the specialization of applications of power electronics in the power systems, hardware deployment and power quality, and different adaptive filtering methods, nonlinear control, and EV and PV aspects as the utility applications. And I have been serving here as a faculty member since the last 1.5 years in the Department of Electrical Engineering. So I am currently dealing the machines 2 subject here for the UG students, BTech electrical engineering students. Since this syllabus has been revised recently as per the new academic curriculum under BPUT, so this faculty development program for each subjects, mainly focusing on the core subjects, especially subjects like machines, would be definitely useful to accompany with to get accommodated according to the new syllabus as well as upcoming semesters for the different as what continuing students. So I hope these concepts will definitely make a great impact if we teach them students in a familiar way. So rather than showing the PPT and just discuss the existing things, I would like to discuss an in-depth analysis of this particular concept. So entire electrical machines I am going to deal this way. So let us be, I am thinking to discuss in a deeper actual understanding, so that the better we understand first as a faculty, then we can make sure at least the students may get some idea technically inside of these aspects. So before going to the actual concept as per the new syllabus of electrical machines, broadly they are categorized as, let me have a prerequisites of so far what we knew and what it has been discussed during this program. Let me have a quick recap, then we will actually go into the main concepts. Though the terminology and the notations are similar, so some way or the other I may follow different notations. That is why this prerequisite discussions is important. I am thinking, so let me cover the basics for a little time, because if you say for example the flux can be represented by a symbol pi, right? The phase angle we use to represent a symbol phi, right? Theta is also there. So some may use theta for phase angle, current and voltage relation. Some may use phi for phase angle. So here I will use something different. You might follow some other notations. So that is why let me have a quick review of that. So this machines 2 syllabus starts with AC machines, rotating machines, 3-phase and single-phase. 3-phase machines broadly categorized as generators and motors, right? So 3-phase generators, we call them as synchronous generators. Please remember the term. There is a significance of the term synchronous. Generators, usually it should be generators. Why the term synchronous? We are going to discuss that. Then the construction, broadly synchronous generators are constructed by rotor construction, because stationary armatures, bulk in power generation, we take the fixed windings so that power can be taken out flexibly without cooling arrangements. With the rotating parts, if you want to extract most of the efforts and the control aspects and many other non-economical and unstable requirements are posing in nature. So stationary armatures are usually employed for industrial practice at large power levels. So rotor constructions, so depending on the pole type, right, they are salient pole for low speed machines, and cylindrical rotor type high speed machines. Thereafter we come to armature windings, right. The windings are placed on the stationary armature in a particular manner, so armature windings to reduce the harmonics and many other effects, like in synchronous machine especially hunting effects, right. So armature windings are definitely playing a major role for the design aspect. Then after that we come to the characteristics of the alternators on no load as well as on load, how the generators, three-phase alternators work. We theoretically first analyze, then after the industrial practice comes into picture upon the having the clear view theoretically. So these all should be running in mind first simultaneously. Student has to capture this. Otherwise, going to the industry and seeing the practical alternator and what he has studied at the during his graduation level, there should be some coordination. Then only students find some interest of learning. So if we can relate something what he learned in classroom to the actual applications, then only the session would be effective teaching. That way, student finds usefulness out of learning this subject, and he may justify of taking his branch in electrical engineering. So we are going to see. Then operation of alternators on load and no load. Why? Because it is simply a voltage generator. If we consider generator, either DC or AC. Generator means it should generate. That's it. A voltage generator. Even at the load application also it should generate the same voltage. Even at no load operation also it should generate the same voltage. But practically it does not happen like that. Even though how lesser the wire, say conductor resistance may be, there exists a drop. When you are generating voltages in terms of kilovolts range, say 0.1 ohm resistance also will have a major loss. Loss means drop. So what we generate is not what we deliver, voltage. So that is being termed as a drop, voltage drop. So we have resistance drop and leakage reactance drop also. Leakage reactance. Armature windings are nothing but coils. So when they are coils, there exists a phenomenon called inductance. Mu n square A by L, the fundamental formula for deriving the inductance. So where n is the number of turns of a coil, A is the cross section area, and L is the length of the winding. Active length of the winding. So when the inductance comes into picture with respect to the supply frequency, there comes a 2 pi FL. Say phasor if you want to represent, then J. We introduce a complex term called J XL. So there introduces inductive reactance. It is a broadly we can make student to understand this reactance concept as it is a resistance offered in the AC supply, because the resistance in the DC I are drop. So due to the armature resistance, it inherently exists by the property of the material of the conductor, armature winding material. Apart from including this resistive drop, we have reactance drop also. Together we have impedance drop. Resistance plus phasor sum of this resistance drop plus reactance drop will incur an impedance drop from the generated voltage. If we say E naught, I will denote the generated EMF of an alternator, say per phase or three phase, E naught, if I say per phase equivalent. Then the terminal voltage say V. So E naught and V, they are not equal. So there exists a drop. Here comes the concept of regulation. We need to maintain constant voltage. Constant voltage. Why? If we see the EMF equation of this three-phase alternator, E is equal to 4.445 F Kp Kd in that. So all of the other parameters are constant, treated as constant. For a particular machine design, all the other parameters are constant. The only variable term is E is proportional to flux. That is what we call excitation. The main field flux excitation depends directly to the generated EMF. This varies the generated EMF. Terminal voltage we want to maintain constant means this meaning of flux established resultant should be maintained constant. Flux must be constant. So we are going to take that into consideration. So in order to maintain this flux constants, there are two types of fluxes which actually take place inside an electrical generator, say either motor or generator machine. One is main field flux. Main field flux, because in the rate of change of flux cutting is what we call EMF generation, right? So EMF is induced when you connect the load. So main field must exist. As per the fundamental Faraday's law, there exists one main field. When you connect the load, EMF when connected to load, it forms a circuit, so it draws armature current. When armature current is now flowing through the windings, now it will produce its own magnetic field. So that flux created by this armature current, now we represent that as armature flux. So when armature flux and main field flux are two fields are existing now. Now they will interact. Here comes the concept of armature reaction. So armature reaction depends on the load. If the load is say resistive, this armature current and induced armature flux are in phase. If the load is purely inductive, those flux induced by the armature currents will be completely lagging behind the voltage generated. If these are capacitive loads and they are leading, those induced flux by the armature. So when this flux produced by the armature is varying, then main field flux is constantly, we make them rotate, say in a rotating rotor pole type, stationary armature type machines. Then armature reaction. When armature reaction is existing, together they are causing total drop. So in order to maintain the terminal voltage constant, we need to regulate this generated voltage as per the resultant flux and the required terminal voltage. We are going to solve some numericals, then we will understand. I am just giving a quick recap of what we knew already up to now. Then after, characteristics of the alternators. So on no load and on load, OCC. Then we have different methods to find the regulation. EMF method, EMF method, ZPF method, several methods. Then after having all these characteristics, say, are with us, this data is with us. Now we want to operate these alternators in parallel. So here comes the question, why to connect in students' minds. So as we knew it already, when the students gets this doubt, why to connect this in parallel? Immediately, as a naive fresh applicant or fresh aspirant learner, if you say to connect these generators in parallel, they will get a doubt immediately, why not in series? Simply, yes, we know, we can make them by interacting, by asking these questions. Why not to connect them in series? Yes, if you connect in series, what will happen? Generally, two voltage sources are connected in series, resultant voltage will never be constant, it will change. It will be the algebraic sum of the connected voltage sources. Series connection, current would be constant as per our basic electrical circuits analysis. Right. Then, if you are connecting in parallel, what is the requirement, necessary, and advantage? If you are connecting the voltages in parallel, number of voltage sources can be connected first, so that what is becoming constant and what is becoming changing. Voltage is becoming constant. Usually, it must be constant. That is a prime condition for operating the alternators in parallel. First, otherwise KVL violates. When the law violates, system collapses. Two voltage sources of different voltages, if we connect them in parallel, KVL violates. So we cannot connect them. Still, practically, they vary. We cannot make 100 volts, or if it is lesser voltage, okay, we may get lesser effect. But when you are generating power at kilovolts range, megavolts range, say kilovolts range at industry, megawatt range at power output, then even 100 volts difference between two alternators also will impact a larger impact, circulating currents. So that time, so that is inevitable, unavoidable, that happens. So then how to handle them? So what is the theory analysis behind that? So such calculations and concepts we will discuss here briefly in today's session. So what are the technical aspects behind them? Alternators, when are to be connected in parallel? See, we can connect two alternators in parallel to meet the load requirement. All generators cannot be placed or employed at the same location. We have different ways of power generation: thermal, hydro, and renewable energy sources, and others way of nuclear power. So we have multiple locations, multiple ways of power generation. But all these powers should be coordinated to meet the actual load demand, right? So for that we need to maintain some standards. The first standard is maintaining the frequency of this entire grid must be constant. Frequency. and this frequency is associated. Can I have a little interaction from our audience that what parameter will affect that frequency, supply frequency? Can you have any?
The speed of the
Yes,
the
yes,
speed
yes.
of the alternator.
Yes, good. So NS, synchronous speed. So prime mover input defines the synchronous speed, the frequency of this grid system. So if that is varying, it means input side something which is causing that frequency. We have that formula N is equal to NS is equal to 120 F by P. And we can have the simple derivation of that also. If a two-pole machine, one conductor coil. So from north to south, again south to north, one complete rotation, it will give one complete wave. Say for example, one rotation per second is the frequency at which. Frequency is number of oscillations per unit time, per second. Oscillations are caused by the rotation of the prime mover, or we can say the relative motion between the conductor and the magnetic field. If we assume, students may get familiar with this. I am not, please do not take it otherwise that I am teaching from the basics to the faculty members. So we are just discussing. You can also suggest, there are many senior faculty members are also here. So you can also suggest. Together we will learn, we will develop, then we will educate the students for eventually. So that the purpose of this program would get successful. Students should get the benefit, they should get the interest. So I am open to discuss. I am open to accept if you give any comments or any suggestions during the discussions also. So I am exposing my learning throughout these many years of experience in my research as well as teaching experience. So this synchronous frequency. So in order to maintain the constant frequency, some governing speed that is effective. Then another condition to follow for the parallel operation is to maintain the terminal voltages must be constant. Otherwise, what will happen? Okay, we keep these conditions first, then we will operate these two alternators or one alternator with the bus bar, existing bus bar, because bus bar say we usually call them as a grid. Three-phase supply is happening, okay, existing grid. We call that operation as parallel operation of incoming alternator, some new alternator, okay, it is generating with some voltage, some standard frequency and standard voltage, some power rating, at some different power rating, right? So when the frequency must maintain constant and the voltage is also taken care that is maintained constant. Now there is some other factor also to have taken to take care of is phase sequence. The incoming alternator phase, three-phase alternators parallel operation we are discussing, right? Either two or with the infinite bus bar, both for salient pole type and cylindrical rotor type. So another condition is phase sequence. Incoming alternator R and the existing system, either it is alternator or the bus bar R, they must be connected only in the same phase sequence manner. Otherwise, what will happen? Line to line. If incoming is R, you are connecting it to Y. It is nothing but resulting phase to phase, you are shorting almost.
The ALFC or AGC loop can take care of these whole issues. AVR will take care of the voltage deviations, and ALFC or AGC, they can address both the things, the frequency as well as the voltage issues.
Yes.
So why we need all these? I mean, the
Calculation. Well, yes, some introduction we are discussing before I go into the actual operation, when how these alternators are sharing the load, synchronizing power, synchronizing current, and synchronizing torque. Right. In order to have these understandings, I am just going at the brief session according to my notations. Right. Yeah.
Giving that answer, ALF and ABR, a good question. They can take care of all these things, but at the time of synchronization, what will happen if there will be frequency difference and voltage difference? We don't want to suddenly give, practically control. Because synchronization ଆମେ କରୁଛେ ଆମେ ଆगे ଫାଷ୍ଟ କଣ୍ଡିସନ ହେଲା we will keep the machine in no load condition. Rated voltage, rated frequency first we will maintain. ଆପଣଙ୍କର ଗାଇଡ୍ ଲାଇନ୍ଟା କେମିତି ଓପନ୍ ହେଉଛି ଆପଣ ଯେତେବେଳେ ଗାଇଡ୍ ଲାଇନ୍ଟାକୁ ଓପନ୍ କରିଥିବେ ଷ୍ଟିମ୍ ହଉ କି ୱାଟର ହଉ ଆପଣ ସେତିକି ୱାଟର ସେତିକି ଷ୍ଟିମ୍ ଦେଇଥିବେ ଯିଏକି 50 of frequency ମେଣ୍ଟେନ୍ କରିବେ। ଆପଣଙ୍କର ଏକ୍ସାଇଟେସନ୍ ଭୋଲ୍ଟେଜ୍ କେମିତି ମାନେ ପାଏ 80% କିମ୍ବା 90% ସ୍ପିଡ୍ ହେଲେ ହେଲା ତାପରେ ଆପଣ ଏକ୍ସାଇଟେସନ୍ ଆକ୍ଟିଭ୍ ହେବ ଆପଣ 20% ସ୍ପିଡ୍ ବା 30% ସ୍ପିଡ୍ରେ ଏକ୍ସାଇଟେସନ୍ ଆକ୍ଟିଭ୍ ହେବ ନାହିଁ ସେମିତି ପ୍ରୋଟେକ୍ସନ୍ ସିଷ୍ଟମ୍ ମାନେ ଥାଏ ମାନେ ଆପଣ 90% ସ୍ପିଡ୍ ହେଲେ ଆକ୍ଟିଭ୍ ହେବ ଆପଣଙ୍କ ଏକ୍ସାଇଟେସନ୍ ସିଷ୍ଟମ୍। एक्साइटेशन सिस्टम में कौन हम रेटेड वोल्टेज से मेंटेन कर आपण कहीं आमेटा करूचे आमे कहीं की सपोज आमे रेटेड वोल्टेज रेटेड फ्रीक्वेंसी रेटेड वोल्टेज और रेटेड फ्रीक्वेंसी में कहीं हम करूचे आपण जे कंट्रोल रूम को जिवे कोन से पावर हाउस में कंट्रोल रूम को जिवे आपण को थिबो 100% ओपनिंग 100% ओपनिंग मींस आपण को जे रेटेड फ्रीक्वेंसी तो रेटेड आपनकर वोल्टेज मेंटेन करियो नो लोड कंडीशन में आपन जोटा आपको बोलथि तापरे कोन आपन 100% ओपनिंग रही तो तले आपन रेटेड फ्रीक्वेंसी पाई चंदी तापरे आपन के ग्रिड को कनेक्ट करिया चाहउछंती सेते आपन कोन करचंती सिकोस्कोप थाइ आपन तो सपोज आपन 50,000 डी मेंटेन करछन सेठी अछि 50.5 आपन को 50 से बढ़िया पड़ियो वोल्टेज जाइबे करिया गोटे सही समय आपण सर पढ़ेबे सिंक्रोनाइजेशन पाए दि तीन मेथड अछि आपण भी पढ़ी देबिला गोटे सिंकोस्कोप मेथड अछि जेटा कि लैटेस्ट हैला लैटेस्ट अछि सिंकोस्कोप रे आपण जोटा कहले इज ऑटोमेटिक प्रोसेस आपण को किछि करिया दरकार नै सिंकोस्कोप ता आपण खाली ऑन कर देबे कंट्रोल रूम रे से ऑटोमेटिकली सेंस करिवो relay अच्छी relay will sense the grid voltage accordingly एठी सेंस करिवो अपन कंट्रोल सिस्टम अछि सेंस करिवो एक्जिस्टिंग वोल्टेज अपन केते रखि जंती सिंकोस्कोप ऑन करिया पूर्व अपन केते वोल्टेज जनरेट हेछि केते अछि सिंकोस्कोप ऑन करसला पर से ग्रिड रो डाटा को से सेंस करू दीटा अपन ग्रिड को डाटा को सेंस करूची और एक्जिस्टिंग डाटा को से देखुची आपण कंट्रोल सिस्टम से पढ़े जानते से डिफरेंस तो देखिए किसी डिफरेंस अच्छी कि यदि डिफरेंस अच्छी आपण लेट आपन आमे कहाँ सहित मैच करबा ग्रिड आपन पैरामीटर गोटे ग्रिड आ गोटे होला इनकमिंग मैसेज आपन कहाँ सहित मैच करबे ग्रिड आपन सहित मैसेज सहित मैच करियो ना मैसेज ता ग्रिड सहित मैच करियो व्हाई नॉट माने ग्रिड लाइन मैसेज सहित मैच करियो you have no control over the grid हला ग्रिड माने आपन को बहुत पावर स्टेशन बहुत जनरेटर is called by different types of generators are connected to the grid हला so you have no control over the grid but rather you have control over the your machine आपन बारे कंट्रोल अछि आपन माने ताको फ्रीक्वेंसी बढ़ाई परिबे कमी परिबे आपन पाखे अछि आपन दीटा कंट्रोल रे दीटा थाए ଗୋଟେ मैनुअल मोड आ ଗୋଟେ ऑटो मोड गवर्निंग सिस्टम रे सिंध मैनुअल मोड थाए आपन इच्छा आपन बढ़ेबे ऑटो मोड रे से ऑटोमेटिकली ओपनिंग क्लोजिंग करियो जोटा आपन कहली डैश करियो से ग्रिड रिक्वायरमेंट अनुसार जो डैश करियो वोल्टेज फ्रीक्वेंसी बा आपन मैनुअल मोड रखिबे आपन बढ़ेले बढ़ियो कमेले कम ठीक अछि जेतने आप सिंकोस्कोप ऑन कर दोती से कौन करे इट विल सेंस द ग्रिड पैरामीटर एवं एक्जिस्टिंग सहित से कंपेयर करे तो जे एक्जिस्टिंग हम ग्रिड सहित मैचिंग करिया ताले सी ग्रिड पैरामीटर का रेफरेंस एक्जिस्टिंग का जदि हायर
लोअर कराओ
कौन करियो से ऑटोमेटिकली सपोज गाइडलाइन को कमेबो माने इनपुट टाइप से
सर लगी
तो लोअर इनपुट टाइप से बढ़े अपन जोड़ा कहले दैट एक्चुअली सेकंड सेला होची नल कि
हाँ सर ले फोन करबो
कि दाउ को सर एक्सेप्टेशन मतलब से
इन्फिनिट बॉस
हाँ चल
यस इन्फिनिट बॉस आपण इन्फिनिट बॉस खाइबी
सर तार माने तार इनर से
आपण तो जनरेटर गुडा कोन एज कंट्रोल आपण तो जनरेटर सो कनेक्ट करतो दी तार इंपेडेंस ता कोन होची पैरेलल ना पैरेलल में कोन होची तार 1 by less ता कोन
इन्फिनिट हे तो
बुझबो सेते हम बोलते इन्फिनिट बॉस
Difference of voltage variation and frequency variation.
कोडा कोन
Sir, infinite was independent of voltage
The
variation.
infinite burst is what actually শুনু ଆପଣ ଯଦି ଆପଣଙ୍କର ମେସିନ୍ ଯଦି କିଛି କଣ୍ଟ୍ରିବ୍ୟୁଟ୍ କରୁଛି ତ ଆପଣ ଉଡ୍ର କରୁଛନ୍ତି ବିଡ୍ର ସେମିତି ଗୋଟେ କିଛି ୱାଇଡ୍ ଭେରିଏସନ୍ ଅଛି ୱାଇଡ୍ ଭେରିଏସନ୍ ହେବନି ଯେମିତି ସମୁଦ୍ର ଭିତରେ ଆପଣ ଯଦି କିଛି ନେଇ ଯଦି ମଧୁର ପାଣି ବି ପକେଇଦେବେ ଏତେ ଚେଞ୍ଜ ହେବ ତା ଇନଫାଇନାଇଟ୍ ବସ୍ ମିନ୍ସ ଆପଣ ଯଦି ସେ ବସ୍ରୁ କିଛି କ୍ୱାଣ୍ଟିଟିର ଲୋଡ୍ ଉଡ୍ର କରୁଛନ୍ତି বা କିଛି ଅଳ୍ପ କ୍ୱାଣ୍ଟିଟିର ଲୋଡ୍ ଆଡ୍ କରିଦେଉଛନ୍ତି ତାର ପାରାମିଟର ସଡନଲି ୱାଇଡ୍ ଭେରିଏସନ୍ ହେବ ନାହିଁ ଯଦି ୱାଇଡ୍ ଭେରିଏସନ୍ ହେଉଥାନ୍ତା ପ୍ରୋବ୍ଲେମ୍ ହେବ ନାହିଁ ଆପଣଙ୍କ ଘରେ ଲୋଡ୍ ଆପଣଙ୍କ ଘରେ ମଧ୍ୟ ବସ୍ କନେକ୍ଟେଡ୍ ଆପଣଙ୍କ ଘରେ ମଧ୍ୟ ଲୋଡ୍ ଆପଣ ବାଙ୍ଗଲୋର କହିଲେ କାଲି 3 କିଲୋ ଲୋଡ୍ ବନ୍ଦ ହେଇ ରହିଲା ଗ୍ରିଡ୍ ପାରାମିଟର ୱାଇଡ୍ ଭେରିଏସନ୍ ହେଉଛି କାହିଁକି ନା ଗ୍ରିଡ୍ ର ଯେତିକି ଲୋଡ୍ ଅଛି ଆପଣଙ୍କ ଲୋଡ୍ ତାର ପରସେଣ୍ଟେଜ କେତେ
0.0012
very very less but तारा impact parameter ଉପରେ ଏତେ impact ପଡ଼ିବନି ଦେଶ ଆମେ ଯେତେ ଗୋଟେ infinite ତ ଆପଣଙ୍କ ଯୋଉଟା ଯଦି ଗୋଟେ ଆପଣଙ୍କର ଯଦି ଗୋଟେ 1000 ମେଗାୱାଟ ଯଦି କମିଯିବ ତାର impact ଯାହା ରହିବ ଆପଣ 3 କିଲୋୱାଟ ରେ ତାର impact କଣ ହେବ impact ଅଛି but that is not visible ଆଉ ଆପଣ ଯୋଉଟା କହିଲେ ସେଟା ହଉଛି सिकोस्कोप यदि आपण ऑन करतोंती से जिनसटा हाउसिंग नहले केमी से मैचिंग करती फ्रीक्वेंसी वोल्टेज ता मैचिंग करके तो ऑटो सिंक्रोनाइजेशन करछि ना आपण पावर से जो दिबे गुडे सिकोस्कोप अछि सेठी ऑन कर देले आपण बा कुछ करे दरकार नै से वोल्टेज को मैचिंग करियो एवं फ्रीक्वेंसी को मैचिंग करियो आपण जोटा कहले से दीड जाक पैरेलली एक्टिव हेकी मैचिंग करियो जेते बेले मैचिंग हे जो आपण ऑटो क्लोजिंग हे जो ऑटो क्लोजिंग है
Laboratory also it is provided.
ऑटो आपण जते मैचिंग करे जाउछंती जते सिंक्रोनाइजेशन करियो ना आगे कोन करियो देखो आपण तो ग्रिड रहिला प्रेसिंग रहिला ହେଲା मझिर रहिला आपण तो सिकोस्कोप ग्रिड परे बसबार परे तापर ब्रेकर तापर आइसोलेटर ହେଲା आइसोलेटर सप्लाई आसे आपण तो सिकोस्कोप आपनकर मेसिन सप्लाई होची सिकोस्कोप पाखरे अछि कनेक्टर माने से होची ऑटो क्लोजिंग होबा ऑटो क्लोजिंग केते रहबो जेतेबे दीटा को पारामीटर डिफरेंस ता 0 हो फ्रीक्वेंसी ता 0 हो साइमल्टेनियस सीबीरा पारामीटर 0 हो गुटे से ऑटो हो वास आपण जो इंस्टॉल कर देचंती देयर विल नो चेंज इन फेज सीक्वेंस तो फेज सीक्वेंस ता नॉर्मली गुटे थर करा जाय जो मशीन डाटा प्रथम एत इंस्टॉल करा जाए फेज सीक्वेंस को सेट कर टेस्ट करा जाए वास मशीन इज इंस्टॉल सब थरो आपण माने प्लान पढुछनी कोन फॉर पैरेलल ऑपरेशन 3 कंडीशन शुड बी सैटिस्फाइड वन इज वोल्टेज शुड बी सेम फेज सीक्वेंस शुड बी सेम एंड फ्रीक्वेंसी शुड बी सेम प्रैक्टिकली फील्ड रे है हां गुटे थरो फेज सीक्वेंस को कर जाए टेस्ट करा जाए इंस्टॉलेशन टाइम फेज सीक्वेंस भी हेला आपण तो कनेक्ट कर देले ना पूरा हेला ना रहिला ना आउ तो सेटा वेरिएशन होबो ना खाली आपण वोल्टेज और फ्रीक्वेंसी ये दीट जाक आपनकर सिकोस्कोप रे आपनकर ऑटोमेटिकली सिकोस्कोप मोड रे रखतोती आपण मैनुअल मोड रे कर पारबे ऑटो मोड रे भी कर पारबे सिकोस्कोप ऑटोमेटिक करले माने मैनुअल मोड करले आपण କରିବା ପଡ଼ିବ ଯେ କ'ଣ ଅଟୋସ୍କୋପରେ ସିଙ୍କୋସ୍କୋପରେ ରଖିଲେ ଅଟୋମେଟିକାଲି ଦୁଇଟା ପାରାମିଟର ଡିଫରେନ୍ସ ଜିରୋ ଆସିବ ସେଇ ସମୟରେ ଅଟୋ କ୍ଲୋଜର ହେଇଯିବ। ଅଟୋ କ୍ଲୋଜର ହେଇଯିବ ମାନେ ସେ କାହାକୁ କ୍ଲୋଜ କରିବ? ବ୍ରେକରକୁ କ୍ଲୋଜ କରିବ।
ब्रेकर को क्लोज करी वाल्व को
ବ୍ରେକର କ୍ଲୋଜ କରିବ। ତ ବ୍ରେକର ଯେତେବେଳେ ସେ କ୍ଲୋଜ କରିବ ତା ପୂର୍ବରୁ କୋଉଟା କ୍ଲୋଜ ହେଇଥିବା ଦରକାର? ଆଇସୋଲେଟର। ସେଇଥିପାଇଁ ଆଇସୋଲେଟର ଇଜ ଏ नो लोड डिवाइस और इस ब्रेकर इज ऑन लोड डिवाइस। तो आइसोलेटर टा सब नो लोड कंडीशन में आप ऑपरेट करिए, लोड कंडीशन में केबे भी ऑपरेट करिए नहीं। अब ब्रेकर को ऑन लोड रे आपण जो चले जाए ऑन लोड एट लो पावर हाई पावर रे कले कोन हो स्पार्क ले ब्रेकर नष्ट हो जाए। तो प्रैक्टिकली तो लोड इंजेक्शन करा जाए कौन करेगा आपन गोटे यूनिट टा बंद करिया चाहते केतल कौन करिए आपन कौन करिए आस्ते आस्ते हाई लाइन को इनपुट को कमेले आपन को इंडिकेटर देखियो जे लोड जा मशीन पर थला से कमी आसुची। तो 5% लोड थिबो 5 मेगावाट की 3 मेगावाट की लोड थिबो सेही कंडीशन सपोज आपन 50 मेगावाट को मशीन आपन को इंस्ट्रक्शन आसला स्टेज लोड डिस्पैच सेंटर आपन जानते एसएलडीसी व्हिच मॉनिटरिंग ऑल द पावर स्टेशंस। सपोज इंस्ट्रक्शन आसला जे ग्रिड रे आपन फ्रीक्वेंसी बढ़ी जाउची आपन 5टा यूनिट अछि गोटे यूनिट बंद करन एंड यू टू ओबे देयर ऑर्डर आंसर ऑर्डर को आपन मानिबे नने आपन चार्ज शीट देइबे because they are responsible for grid stability। आपण कहले जे मो इंजीनियर अछि आपण ऑर्डर मानिबे आपण समस्त तांको ऑर्डर मानिबे आपण कोन दृष्टि गले बंद आपण जिवे फंक्शन ब्रेकर टा कोन करिवे ऑफ करिवे संगे संगे आपण स्विच धुआ मय कोन करिवे 50 मेगावाट आपण लोड अछि आस्ते आस्ते आप रिड्यूस कर करिए रिड्यूस करी दिबे करी की तो 3-5% लोड 5 मेगावाट की 3 मेगावाट थिबो सेही समय रे ब्रेकर को ऑफ करबे तापर आइसोलेट ऑफ हे ब्रेकर तापर आइसोलेट ऑफ करबे मिलो सिंक्रोनाइजेशन समय रे आगे आइसोलेट तापर ब्रेकर सिंकोस्कोप निजे ब्रेकर बंद करबो और आपण जोडा पचले सेटा खुज नहले दुईटा एक साइमल्टेनियसली हेबेले ऑटोमेटिक मिथे यदि ऑटोमेटिक वोल्टेज रेगुलेटर आ गवर्निंग सिस्टम यदि काम न करे त की मैचिंग करेबो सेटा खुज।
So as we are discussing, there are two fluxes inside the alternator. One is the main field flux and another one is due to the armature current, armature flux. And the interaction of these two fluxes usually cause an effect called electromagnetic torque inducing inside the synchronous generator. Usually we get motor output as a torque, mechanical torque. But what is electromagnetic torque? Role of electromagnetic torque in a generator. Generator torque is nothing but prime mover torque. But there exists a phenomenon called electromagnetic torque inside the three-phase alternator due to the interaction between the main field and armature field. Say main field flux phi m, I denote here as phi m, and phi a. Interaction of two fields is either we can generically say that whether they attract, like poles attract, unlike poles repel. When these fields are now rotating, when you consider the phasors of these fluxes, two fluxes, they try to align with each other in order to have the uniform torque producing. During this alignment process, so rotor field is always with respect to the prime mover which we are rotating with. That speed is constant. Then flux produced by the armature winding currents. Now these phi A now reacts with this main field flux. Now it tries to establish a resultant flux because phi A is not always constant. Phi A depends on IA, that which in turn depends on the load. If you are connecting a pure resistive load, that IA is in phase with the voltage, pure inductive load lagging, and pure capacitive load say leading. So accordingly, phi A also varies. So this phi A and phi M need not to align in the same direction always. So they react. During this reaction, in order to have a stable operation of the alternator, there is an introduction of synchronous electromagnetic torque introduction, and it always tries to make this resultant field rotate at a constant speed. This process theoretically is known as synchronous speed. Synchronous speed is generally we say that since the prime mover input is constant, so that is why we talk that as synchronous speed. Usually the depth inside of this general statement is trying to align the reaction caused by this armature flux and the main field flux. They always try to align with each other and rotate with a constant speed. That is why it is known as synchronous speed. It happens, it should happen. So what is the theoretical depth analysis inside that? We will see. And the angle, when they are not in phase, when they are not usually or need not be necessarily aligning for any type of loads. So there exists some angle between the armature flux, and if you take the phasors of those rotating fields, then that angle we call it as torque angle or load angle. This is what load angle. For synchronous generators, we represent usually that with a term called delta. Delta is the torque angle or load angle. That is also called as power angle. We will define what is that power, synchronous power, synchronizing torque, and what are the numerical and theoretical analysis along with the diagrams, phasor relations, theoretical aspects. We will discuss. After this, while connecting two alternators in parallel, how these are going to affect. That analysis we are going to see now. As I introduced the term as the term called load angle. So while drawing the phasor diagram of three-phase alternator, say this generator, synchronous generator, we take say a terminal voltage as constant. Right? We will understand this. Though it is familiar to you, we will have this quick recap of these to get accustomed with the notations that we are going to follow in our further discussion. So, say per phase voltage, taking that as a reference, phasor, V is a phasor because a rotating vector is called a phasor, so we are representing V as a phasor. Take some lagging load, inductive load, not pure inductive. So that IA need not be necessarily with in phase with V phase voltage. So IA armature current lags behind the voltage. This is the anti-clockwise is the rotation plane, complex rotation plane. Then IA lags behind the phase voltage. The angle between V and IA, terminal reference voltage we are considering, and the lagging current is now taken as phase angle. This is phi. Two angles we are introduced now as of now. One is load angle, flux angle from armature flux and as well as main field flux, and phi is the phase angle. Then we discussed just now armature current, due to the passage of armature current and resistance and reactance, they cause the impedance drop. IA RA plus IA XS. XS leakage reactance as well as armature reaction causing the armature reactance. And the drop caused by these is denoted by IA ZS. So phasor sum of these resistive drop and reactive drop together will give us the impedance drop. Sum of this reference plus the drops will give us the actual generated EMF. So now there exists a voltage, the angle difference between the generator and the terminal. Ideally they should be same. As per our law, generator voltage must be same as the terminal voltage, but theoretically and practically also there exists an angle. That angle is nothing but the load angle. Here again delta. Delta is the angle between the E and V. Whereas phi is the phase angle between the armature current and the terminal voltage. Together it is represented as an angle psi. If you take phi m main field flux as a reference, this phi m induces EMF in the armature coil by lagging. EMF induced by due to this flux lags behind the flux. Faraday's law. Right? If you are considering salient pole machine, since we have understood up to now that two major types of rotor constructed alternators are available, namely salient pole and cylindrical rotor. In salient pole, we have two polar axes. One is direct axis, which is passing through the poles, and which is in quadrature with this direct axis. We have another axis, say interpolar axis, that is called quadrature axis. So Q axis and D axis. Right? For the salient pole machine, this armature current now with respect to the armature flux now can be decomposed into two components, D, IT and IQ. From this, after this mathematics, so we can project this V onto E. If this is delta, this is V cos delta, this is V cos delta. Then after the remaining gap, E minus V cos delta is this. So the phasor sum of the EMF generated inside the salient pole alternator will be represented this as here. So we are getting no load voltage as V cos delta plus IQRA plus or minus ID XD. It can be derived from this. So whereas plus is for lagging power factor load and minus is for leading power factor load. Okay, why are we discussing this? So there exists a term when these two fluxes are interacting. We got introduced the term called synchronizing torque. Electromagnetic torque, right? This torque causes something to operate this machine alternator stable by introducing a term called, it is a concept called synchronizing power. Then what is the synchronizing power? Okay, as we discussed, delta is the angle between the no load voltage and the terminal voltage. Phi is angle between V and Ia. Psi is the sum of load angle as well as phase angle with respect to the lagging or leading power factor loads, and this is the expression. After this, yes, synchronizing power. Synchronizing power. What is synchronizing power? Usually, it is the rate at which synchronous power varies with respect to delta. dPsy, that is synchronizing power coefficient. So, synchronizing power coefficient is the synchronizing power. We are going to see how this synchronizing power affects, because when you are trying to connect two alternators in parallel, adjustment happens initially. One machine, if the voltage input, if you vary the excitation of the one alternator, definitely no load generated voltage varies. Then the difference exists between the two alternators, terminal voltages also. Then how they react inside them in order to have the synchronous operation. So for that, these terms are first introduced. Synchronizing power coefficient is nothing but the rate of synchronizing power at which the load angle with respect to the the rate at which the synchronized power varies with respect to the load angle delta. PSY, dPSY. The PSY is equal to dP by delta. That is giving the synchronizing power coefficient. Yes, its formula it can be derived from our power flow equations. Anyway, we are going to see again power flow equations quickly, a one page derivation from them. PSY is defined as EV cos delta by XS. This itself is synchronizing power coefficient here. Okay. It also gives the stability of the alternator. It measures the stability. So stability is directly proportional to synchronizing power coefficient, which is nothing but 1 by XS. We also call it short circuit ratio. It is nothing but the ratio of the main field current at which the alternator gives its rated open circuit voltage divided by main field current at which the alternator gives rated armature current under short circuit condition. IFM by IFA, that is what? Short circuit ratio. We got this in our syllabus. So as a fundamental definition, so we are knowing these theoretical formulas. Then after, based on this quantitative knowledge, then we are going to analyze the actual operation when we are actually connecting the alternators in parallel. So synchronizing power usually relates with stability. So it is a direct proportion. Okay. Then power flow equations. Yes.
One question about the equation दिला कौन? That is EV
XS.
E by XS. E and B. B is terminal voltage. E is induced voltage. Both are nodes and नहीं. ताले हमें कोटा को हमें कौन हमको कोटा रेस्पॉन्स हम घरू पावर पाइन बट हम जो पावर के डेलीवर करछे ई और बी टर्मिनल वोल्टेज बी ताले ई दा नोड वोल्टेज ये सुन तो V डिपेंड्स ऑन E V टा जब कांस्टेंट रखुछे E टा को अकॉर्डिंगली हमको बढ़िया पड़ो सो दैट V टा कांस्टेंट रहे ताले V टा किमी इफेक्ट हो आर्मेचर करंट E माइनस IA XS इक्वल टू V नहीं तो आर्मेचर करंट का जिते बढ़िबो ड्रॉप से अधिक हो V टा से कमी को चिंता करो नो लोड कंडीशन ता सोले चिंता करो कोन हो प्रैक्टिकली कोन ता V टा कमी हो किंतु आमे करते V कांस्टेंट तल कोडा बढ़िया V रेजिस्टेंस गुडे कांस्टेंट लोड V टा लोड विषय चिंता करो चला लेट 10 मेगावाट लोड और 20 मेगावाट लोड चला 10 मेगावाट लोड रे आपण लोड देई ना E equal to B. Yes or no?
Yes.
Because I no load. E equal to B. आपण तो लोड एत दो चली let 10 megawatt लोड आपण E not get E equal to B record go to supply the quality voltage to the customer. We want the rated voltage. Our responsibility to provide the rated voltage to the customer. Rated voltage का हमें बीटा इंश्योर करें rated voltage. तो दी अपने जो लोड का कांस्टेंट रखी है 10 मेगावाट रखी है लोड. Accordingly आर्मेचर करंट जनरेट हो लोड माने करंट बढ़ी जहाँ बढ़ला नेट हो ताले आपण कोन करियो जो V टा आपण चाहूछी V plus IA access equal to E
ये बढ़े
you to increase the E who increase the E excitation तो automatically
सर ये मतलब इंड्यूस ईएमएफ
और automatically
इधर नो लोड है
increase the field current so that you will get that much of E which will maintain the required amount of V. आउट कैसे डन 20 मेगावाट डन आगे से करंट चेंज हो पुणी चेंज हो दा पुणी यदि सही भी आपण भी कि तो सेटा रखे तो और बढ़िया पड़ो
इन केस रे सर के हमको कंपेंसेटर यूज करे पड़ो
आपण बढ़िया पड़ो बुझ पातो इसी रिगार्डिंग वोल्टेज स्टार्ट ऑफ फ्रीक्वेंसी कौन
लोड बढ़ने से फ्रीक्वेंसी कम होगा
उसमें बुझले ना नहीं आपण वोल्टेज रे एनालिसिस करो फ्रीक्वेंसी रे कौन
फ्रीक्वेंसी कम कर लोड बढ़ने से फ्रीक्वेंसी कम
काहे करो
सर सीओ ची गोटे माने ग्रॉस तो होय जे
फ्रीक्वेंसी माने कोई है ना स्पीड
स्पीड
असली चिंता करो कौन हो सेट में सिलेक्ट करो स्पीड
एनर्जी कैन
शुड स्पीड जेमिति थे आपण देखले कोनटा कहूची ए ड्रॉप ता होची ना ड्रॉप तो होची बोली तो वोल्टेज कम होची ना ड्रॉप होची बोली वोल्टेज का कमची टुडे ओन टोल्ड ना there is a voltage drop due to flow of armature current in opposite direction. That's why there is a voltage drop. यदि आप बोलते हैं I access, voltage drop जो कि कुछ ना voltage drop का vary होती based on the load condition. Voltage drop is varying based on the load condition. अपन voltage को पैरामीटर लेगा जो कि हमें parallel operation में one another parameter is अपन frequency. Frequency कौन होती?
फ्रीक्वेंसी सर लोड स्पीड जतो लोड बढ़े ना स्पीड
बेटा अपन इक्वेशन नहीं कौन हो
स्विंग इक्वेशन में कम जी को
आपण चिंता करते आगे उठे देखो आपण नो लोड कंडीशन है नो लोड कंडीशन ले आपण तो सपोज एग्जांपल मुझे कहूची 10000 लीटर वाटर का स्टीम यूज होतो 10000 लीटर स्टीम किंवा वाटर रे जति की स्पीड आसुतला लेस दैट इज 50 फ्रीक्वेंसी से प्रोवाइड करतो जो स्पीड रे हमें 50 फ्रीक्वेंसी पास एग्जांपल मुझे कहूची आपण लोड देले 200 मेगावाट लोड देले एटी जे वोल्टेज रे आपण पाइले आर्मेचर करंट का पडिला वोल्टेज ड्रॉप हैला किंतु ई आपण बढ़े कारण बी टा आपण फस्टर कर फ्रीक्वेंसी रे कोन स्पीड ता कहां की कम होची
सर के काइनेटिक एनर्जी खर्च हो जाउ छै लोड टा
नहीं हाउ दैट इज रिलेटेड विद लोड
जो द स्विंग
लोड से तो केमिति चिंता कर लोड सहित लोड करंट का केमिति स्पीड को कमौची स्पीड कार स्पीड ये तो रोटर रोटर कौन फील्ड वाइंडिंग अछि कार स्पीड का काहे कमौची हाउ दैट इज रिलेटेड विद द अपन लोड करंट से तो स्पीड रो संपर्क कोन
लोड करंट बोले
लोड करंट से तो बुझली ने पड़ता लोड करंट से तो यदि वोल्टेज रो रिलेशन अछि लोड करंट से तो स्पीड रो रिलेशन
लोड करंट स्पीड कम हो
काहे भी कम हो
सर पावर बॉडी लोड करंट बोले पावर
टेक्निकल जिनिस का कोन बॉडी में कोई आपको पिलर विशेष कर ना
Voltage.
काहे भी टेक्निकल
पावर से करंट आपण कम है
আমি পিলার নিশ্চিত কইলে পিলার हम কথা को विश्वास करू आमे ताकू मैथमेटिकली बुझिया बोले आमे तो करंट तो बॉडी आमे तो वानी रे नहीं इधर आमे जो करंट फ्लो होची ऑपोजिट डायरेक्शन में फ्लो होची अभी कौन बॉडी फोर्स फ्लक्स प्रोड्यूस करची से फ्लक्स का प्ली करची पॉइंट ऑलरेडी टोल्ड जो फ्लक्स ता केलिवानी दोची आर्मेचर फ्लक्स ता ऑपोजिट डायरेक्शन ले आपली रिजल्टेंट फ्लक्स को रास्ता करतो ते आर्मेचर फ्लक्स ता कोड काम लिंक करची केलिवानी लिंक करची तो केलिवानी लिंक कला सेठी वोल्टेज जनरेट होबो कि नाही एटी करंट जनरेट हो कि नहीं से करंट से तो एटी करंट जनरेट हो कि नहीं
Yes.
that current will create a force or not
Yes.
F equal to ILB magnetic field अच्छी कि नहीं magnetic field अच्छी ना नहीं अच्छी आपन करंट जनरेट होला को फील्ड रे फील्ड का कहां पर अच्छी रोटर रे अच्छी फील्ड ऑन द रोटर करंट जनरेट होला ऑपोजिट डायरेक्शन रे से स्पीड फोर्स जनरेट होला ऑन द रोटर जो स्पीड रे आपन बुलौथिले से ताको विरोध कला जेते अपोज कला जेते आपन लोड बढ़ाइबे फोर्स का सेते डेवलप हो ऑपोजिंग फोर्स विल डेवलप ऑन द रोटर इन दैट अमाउंट जेते आपन लोडिंग करिवे ना मशीन को सेते तार स्पीड ड्रॉप हो जेमिति जेते लोडिंग करछन आपन वोल्टेज ड्रॉप होची किंतु आई एक्सेस एटी मो सेमिति मध्य आपन रोटर वाइंडिंग रे आ फील्ड वाइंडिंग रे सेते वोल्टेज जनरेट हो बिकॉज़ phi is proportional to IA
opposite voltage.
opposite सेते वोल्टेज जनरेट हो वोल्टेज जनरेट हो सेते करंट जनरेट हो फील्ड वाइंडिंग सेते कोन हो opposing फोर्स जनरेट हो तो आपण कोन करिवे आपण नो लोड कंडीशन ले आपण जहा सपोज एग्जांपल आपण कहली 10,000 लीटर वाटर आपण टरबाइन ऊपर इंजेक्ट करथि फर्स्ट इंजेक्ट करथि आपण डाक्टर फ्रीक्वेंसी पाउथि से फ्रीक्वेंसी आपण कोन कले सिंक्रोनाइज कर दे से फ्रीक्वेंसी आपण सिंक्रोनाइज करि जदि मतलब लोड आपण स्लोली बढ़ेले 5 मेगावाट लोड देले वर्तमान आपण रोटर स्पीड कोन हैला कमिला पता सिंक्रोनिज्म रहइबो कि नहीं रहइबो कि रहइबो ताले कोन करिवो गवर्नर रनिंग सिस्टम देखो मोर जहां वाटर 10,000 लीटर जाइतिला तार आहुरी अधिक एडिशनल दबो जेति के ऑपोजिशन ला प्रोपोर्शनल दबो से 10,000 जहां थिला रहिला जेति के ऑपोजिशन ला प्रोपोर्शनल वाटर देला पुनी अपन 20 मेगावाट बढ़े देले आउ अधिक दबो बुझि पछुंती सिमिलरली व्हाट लोड रिजेक्शन तो थाकी जागा 10 मेगावाट अपन रिड्यूस कर देले कमियो पुनी को रिड्यूस कर देले कमियो मु आपन जडा कहि आपण काहे कि 20 मेगावाट रे ब्रेकर डायरेक्टली ऑफ करियो नहीं स्विच तो डैमेज हो आपण टरबाइन सिस्टम मध्ये डैमेज हे जिवो काहे कि आपण सडनली यदि ब्रेक जदि विड्रॉ कर दो जदि लोड आपण केते वाटर बटन इंजेक्ट करछंती 10,000 ऊपर 10,000 ऊपर जदि सडन रिजेक्शन होउची तार वाइब्रेशन कोन हो ताकि अपोज करथला ता वाइब्रेशन कंट्रोल ले थिला आपण का फ्री हे मासे ताको अपोजिशन नाही किंतु आपण केते वाटर फोर्स इस्ता है कोई वाइब्रेशन क्रिएट हो whether the turbine system is designed to sustain that much of force it no उठी के ऊपर पड़े वो बीएचएल बैंगलोर रे ट्रेनिंग होती है तबे 2004 रे और देवी मेटल लिमिटेड रे सेति आपको ट्रेनिंग होती सन कहले यदि आपण केयर पिलो दी टू नॉट कंट्रोल द लर्निंग सिस्टम या आपण का पारा उस आटम बम पके mo बुझि पहिले तो सिस्टम देखो जेमिति आपनकर काम को आपनकर फील्ड सिस्टम फ्रीक्वेंसी आपनकर वोल्टेज मेंटेन करूची फ्रीक्वेंसी रे ମଧ୍ୟ सेम थिंग जेमि सेति एक्साइटेशन को बढ़ाउछंती एटी सेमिति आपनकर इनपुट रे ମଧ୍ୟ बढ़िबो आपण आपण भी कहबे स्पीड ता कमी जिवो पिला विश्वास करिए काहे को भी आगे हम तो पहिले तो सिमिति ला विश्वास करिए आमे मैथमेटिकली आपन बुझिया पड़ो काहे कि सेठी कमिबो रोटर के कोठी कमु स्पीड ता रोटर रे कोन इंपैक्ट आर्मेचर करंट रे रोटर रे इंपैक्ट आपन मैथमेटिकली बुझे आ समिति कहि देले तो केई विश्वास करिए और पूरे मुझे विश्वास करिए आ बुझला वाला जानबे तार सब आंसर आपन पाइबे देखिए आपण काहे कि 3 मेगावाट बा 2 मेगावाट रे काहे आपण स्विच ऑफ करिवे माने लोड काटिबे व्हाई नॉट एट 20 मेगावाट 20 मेगावाट रे कले कोन असुविधा हो देखरे तो प्रॉब्लम हो टरबाइन सिस्टम रे मतलब कोन हो मतलब मॉडर्न बोर्ड लागिछि ना से वाइब्रेशन बाय जहां डिजाइन होछि से ठीक तो वाइब्रेशन से सर्टेन करियो ना तो सब आंसर आप पिला पचारे से पाइबे सब आंसर तो जोटा आप पाइलर ऑपरेशन रिक्वायरमेंट होची आपण से एजेगा माने एक्साइटेशन जेमती वोल्टेज कमुची एटी मध्य स्पीड कमुची स्पीड आल्सो डायरेक्टली लिंक टू द मेथड कारण अधिकांश हम कोई बही लेखा है आप देखिए यही जिनसा कोई बही लेखा है कौन सी बुक्स लेखा है मुझे देखी
काउंटर टॉप दे छोटे काउंटर टॉप
काउंटर बिजनेस करते मैं डायरेक्ट इन लेखा है मुझे तो ऑपरेशनल फील्ड आई एम लुकिंग आफ्टर द एक्साइटेशन सिस्टम गवर्निंग सिस्टम फ्रॉम माय एक्सपीरियंस व्हाट आई हैव सीन व्हाट आई हैव डन इन द फील्ड आपन बेटा मु बोली
सर पावर हाउस रो लोड के रिजेक्ट करियो
और पास लोड रिजेक्शन एमती हुए आपन लोड काटिबे एमती आपन कहली ना आपन को आपन कमी लोड आस्ते रिड्यूस करिवे
When they will contact the system operator, they will shut down the loads slowly and steadily from
आपन
different
रिडक्शन प्लान लोड रिडक्शन सो द रिडक्शन प्लान लोड रिडक्शन आउ हेला होची माने इमरजेंसी लोड रिडक्शन काना सपोज कोन हो ता ग्रिड फेल्युअर हेला ग्रिड फेल्युअर सेमिति चांसेसटा बहुत कम ग्रिड फेल्युअरटा पुरे सडनली हे जाय आपण हम जानि परिबे ग्रिड फेल्युअर होबा जाउ
cascading effect is
एदर फ्रीक्वेंसी बहुत डाउन एबे एक सिचुएशन नाही आपण 2000 रे देखिबे हला गुटे दिन रे 3 टाइम्स ब्लैक आउट इज स्पीड 3 टाइम्स सेतेबेले काइना सेतेबेले एडवांस गवर्निंग सिस्टम और एक्साइटेशन सिस्टम्स आर नॉट अवेलेबल एडवांस देखो पुरा देखो से फॉल्ट हेले जाय छेले आपण इंक्रीज और डिक्रीज व्हाटएवर मे बी इट विल टेक सम टाइम आपण सडनली पुरा गवर्निंग सिस्टम एक्साइटेशन भाव मुझे समझ एक्शन कर दो सी एक्शन करबो आपण गवर्निंग सिस्टम के एक्साइटेशन सिस्टम गवर्निंग सिस्टम रे पुरा इलेक्ट्रिकल सिस्टम है इट विल क्रिएट द सिग्नल फाइनली ऑपरेशनल और मैकेनिकल पूरा भाग दा गुटे गाइड रेंज को ओपनिंग क्लोजिंग इट इज ए मैकेनिकल सिस्टम गवर्निंग सिस्टम रे कंट्रोलर इट विल माने सेंस द your data from the grid situation the data will sense and it will give the command to the transducer will control the oil pressure and that oil will go to the governing system that will operate the governing system your guide rail is a mechanical system ये जो total process करिया पे it will take some time सही टाइम भीतर यदि ग्रिड यदि रोइला तो ठीक अछि न रोइला तो सरिला
Sir, actually PMU use है, SCADA use होता है, बने अभी PMU रे second में getting
electrical type ये जहाँ use करो mechanical it will take some time ना
yes
electrical आप हम जहाँ करो mechanical it will take some time instantly आप भाई ने फट फट की ना सांग नहीं excitation system नहीं जो governing system it will take time तो आदिकाली electrical system का बहुत fast रहा digital सिस्टम सब यूज कर रहे हैं तो मैकेनिकल सिस्टम पूरे आपन को इट विल टेक सम टाइम तो सही टाइम भीतर यदि ग्रिड यदि सस्टेन कला देन करेक्टिव एक्शन विल बी टेकन इन द ग्रिड यदि ग्रिड न रहिला आ किछि नाही जेटा कि आगो आपन को 2000 मसिया देखिए ग्रिड बहुत ब्लैक आउट होतला एबे देखिए ग्रिड ब्लैक आउट प्राय नाही आगो नाही तो ग्रिड की आपण को गुटे एक डेटा की पैरेलल एक्सेस में वोल्टेज और फ्रीक्वेंसी हाउ वोल्टेज एंड फ्रीक्वेंसी दैट मींस योर द लोड कंडीशन आर्मेचर करंट लिंक विथ आपण को वोल्टेज एंड फ्रीक्वेंसी और उसी कथा कहला जे स्पीड तक एंटी कम देन द पॉइंट वोल्टेज आपण को बुझान स्पीड तक एंटी कम ಇದೆಲ್ಲ ಆಪರೇಷನ್ ನಾವು ಆರಾಸ್ಕೊಂಡ್ರೆ ಹೆಂಗೆ ಆಪರೇಷನ್ ಮಾಡ್ತೀವಿ
सर मैक्सिमम लोड हम लोग की मोबाइल धीरे-धीरे लोड का करने दी प्रोसेस में
लोड में क्यों देखिए तो आपन को सोचतारू मैं आपन देखिए एक्चुअली पावर हाउस के गवर्निंग सिस्टम था आपन गाइड रेल टेक्निक था आपन रोटर टेक्निक था स्टार्टर टेक्निक था आपन से देखिले विजुअलाइज करले ତାପରେ ମୁଁ ଆପଣ ସବୁ ବୁଝିପାରିବେ ତାପରେ ମୁଁ ଏଠି ଦେଖିବି
ସାର୍ ଆଉ ଗୋଟେ ଜିନିଷ ଆମେ ପଢ଼ିଛୁ
ରେଙ୍ଗାଲି ହାଇଡ୍ରୋ ପାୱାର ଯେଉଁ ଷ୍ଟେସନ ଅଛି ରେଙ୍ଗାଲିରେ ସେଇଟା ମୁଁ କାମ କରୁଥିଲି ମୋ ପାଖରେ ଅଛି ଆପଣ ସେଇଟା ବି ଦେଖିବେ ଦେଖିଲେ ଆପଣ ଜାଣିପାରିବେ।
ସାର୍ ଆଉ ଗୋଟେ ଜିନିଷ ଆମେ ପଢ଼ିଛେ ପି କ୍ୟୁ ଭି ଆଉ ଡେଲ୍ଟା ଭିତରେ କ୍ରସ୍ କନେକ୍ସନ୍ ଅଛି ପି ର ଡେଲ୍ଟା ସହିତ ଭି ର କ୍ୟୁ ସହିତ ମାନେ ଭୋଲ୍ଟେଜ ଗୁଡ଼ାକୁ
ମୁଁ ଅଲରେଡି କହିସାରିଲି
କ୍ୟୁ
ମୁଁ ଆପଣଙ୍କୁ ଅଲରେଡି କହିସାରିଲି
କିନ୍ତୁ ତାର କ୍ରସ୍ କପଲିଂ ମଧ୍ୟ ଅଛି ସେଇଟା ଉପରେ ଆମେ ମାନେ ଯେତେବେଳେ କାମ କରୁଛେ ସେଇଠି ଆମେ ଜାଣିପାରିବା କ୍ୟୁ ଇଜ ଅଲସୋ କଣ୍ଟ୍ରୋଲିଂ ଡେଲ୍ଟା
That I will discuss, sir. That theoretical discussion is with me. Upcoming discussion I am going to discuss. I wrote this. With you.
related with delta and your Q is and delta କୋଉଠି ଆପଣଙ୍କର ଜିନିଷଟା କୋଉଟା ଅଛି ଫିଜିକାଲି ମଧ୍ୟ ମୁଁ ଆପଣଙ୍କୁ ଦେଖେଇବି ଡାଇଗ୍ରାମଟା ଆପଣଙ୍କୁ କହିବି।
That is why I did not make the PPT. It's my own written notes out of taking some standard books. Long ago, I am just directly showing my notes.
ଆପଣମାନେ ଟିଚର ଅଛନ୍ତି ପିଲାମାନଙ୍କୁ ପଢ଼ାଉଛନ୍ତି ଜାଣିଛନ୍ତି ଆମେ ଯୋଉଟା କି ଆମେ ଷ୍ଟୁଡେଣ୍ଟ ଆମକୁ ପଚାରିବେ ଆମେ ସମସ୍ତେ ଚିନ୍ତା କରିବେ ଯେ ଆମକୁ ଷ୍ଟୁଡେଣ୍ଟ କ'ଣ କ୍ୱେଶ୍ଚନ୍ ପଚାରିପାରନ୍ତି ଯୋଉଟା କି ବହିର ଡାଇରେକ୍ଟ ଲେଖାଯାଏନି ଆମକୁ ଷ୍ଟୁଡେଣ୍ଟ କ'ଣ କ୍ୱେଶ୍ଚନ୍ ପଚାରନ୍ତି ଆମେ ଷ୍ଟୁଡେଣ୍ଟଙ୍କୁ ଗୋଟେ ଇଣ୍ଟରେଷ୍ଟ ରେଡି କରିବା ଷ୍ଟୁଡେଣ୍ଟ ଗୋଟେ ସବୁ ଗୋଟେ ଫଣ୍ଡାମେଣ୍ଟାଲ ଆସନ୍ତୁ ଆମେ ଗୋଟେ ପିଲାମାନେ ବହି ପଢ଼ୁଛନ୍ତି ପିଲା ଇଣ୍ଟରନେଟରେ ସବୁ ପାଉଛନ୍ତି ହେଲା ପିଲାମାନଙ୍କ ପାଖରେ ଆଜିକାଲି ସବୁ ଆଭେଲେବୁଲ ଅଛି କୋଉଟା ପିଲାଙ୍କ ପାଖରେ ନାହିଁ ସେଇଟା ଆମେ ପିଲାଙ୍କୁ ନହେଲେ କ'ଣ ପିଲା ଆପଣ କ୍ଲାସ୍ ଆସିବେ ଆପଣ ତାଙ୍କୁ ମୋ କ୍ଲାସ୍ ଆସିବେ ତାଙ୍କ ମୋବାଇଲରେ ଅଛି ଏମିତି ବାହାରିବ 10ଟା ବହି ବାହାରିବ ତାହେଲେ 20ଟା ନୋଟ୍ ବାହାରିବ ବାହାରିବ 15ଟା ଆପଣ ପିପିଟି ବାହାରିବ ଅଛି ନା ନାହିଁ ଶୁଣୁନାହାନ୍ତି ସେ କାହିଁକି ଆମ ପାଖକୁ ଆସିବେ ଆମେ କିଛି ଜିନିଷଟା କହିବା ଯେଉଁଟା କି ବହିରେ ନାହିଁ ସିଏ ରିଏଲାଇଜ୍ କରିପାରିବେ ସେଇଟା ଆମ କ୍ଲାସ୍କୁ ଆଟେଣ୍ଡ କରିବେ ଆଉ ସେମାନେ ଫିଲ୍ କରିବେ ଇଣ୍ଟରେଷ୍ଟିଂ ଏ ଜିନିଷଟା ବହିରେ ନାହିଁ ମୁଁ କ୍ଲାସ୍କୁ ଗଲେ ଜିନିଷଟା ସାର୍ କହିଲେ ମୁଁ ଶୁଣିବି ସାର୍ ନୂଆ ନୂଆ କଥା କହିବେ ଯେଉଁଟା କି ମାନେ ବହିରେ ମୁଁ ପାଇଲେ ଯେଉଁଟା କୋଉ ନୋଟ୍ରେ ପାଇପାରିବିନି ଦେନ୍ ହି ଅର୍ ସି କମ୍ ଟୁ ଆୱାର କ୍ଲାସ୍ ଆମେ ସେମିତି ଟିଚିଂ ଲେଭେଲକୁ ନେଉନଥିଲୁ ନହେଲେ ଆମେ ଯେଉଁ ବହିରୁ ପଢ଼ିବା ସବୁଆଡ଼େ ତ ଅଛି ପୁରା ପିଲା ଆଜିକାଲି ବହୁତ ସ୍ମାର୍ଟ
One more small explanation before going to the actual calculations of parallel operation of power. Okay, after this, just it's a 2-minute explanation. We are going to discuss we already told the armature reaction concept, right? They are interacting, armature flux as well as main field flux. If you take main field flux is usually we consider as a constant flux. Let's say this is the plane of complex plane rotation, phi m is the main field flux. We are taking that as a reference. Induced EMF because of this flux will be 90 degrees lagging behind the main field flux. So how can I draw? Yes. Thank you, sir. This is induced EMF. Just for interaction purpose, I am asking you to just because I am teaching in that way. How I actually teach inside the classroom, I asked to students to inform. Okay. Because of this E, okay, we consider as of now, okay, no armature resistance drop. Armature resistance drop is not. Load is connected. Armature reaction happens due to loading. When you connect the load, say unity power factor loading, nothing but pure resistive load. When you are connecting pure resistive load to the alternator, current flows. Armature current, that current is along with V, IA. E is now in phase with IA. Now flux produced by this IA is instantaneous along with this armature current phi A. So phi m and phi A are now interacting. They are quadraturally interacting. This is called cross magnetization. So armature reaction now is purely cross magnetization for unity power factor load. For say lagging power factor load, ideal case, zero power factor. Lagging is either purely inductive or purely capacitive. 90 power factor, cos 90, 0. So these are also called ZPF lagging. zero power factor lagging. Taking this, why I am telling, so to familiar with the notations what I am going to follow in my notes, in my further explanation. So that is why I am just giving a quick recap. So for lagging power factor loads, okay, if this is a main field flux taking as a reference, induced EMF will be 90 degrees after the main field flux. Now, what is the armature current? Lagging
By 90 degrees.
behind the induced EMF by 90 degrees. So this is IA. Flux produced by the armature current is always instantaneous with the current. So this is a phi A. Now demagnetizing. This effect is called demagnetizing. Resultant flux is now getting decreased. We need to excite more for the ZPF operated alternators to compensate this demagnetizing effect. Over excited machines. We have called it, that concept is called over excitation. Similarly, it is now familiar with leading power factor, ZPF, zero power factor, leading. So ZPF is a lagging, purely demagnetizing. Now, if we are taking purely capacitive load, say 5 E, for purely capacitive loads, currents flowing through the capacitive load now lead the EMF generated. So this is now IA. With this IA, phi A is in phase with IA. So IA and phi A. Now these two are aiding. So these are causing magnetizing effect. The total armature reaction is now magnetizing. But we need to maintain the established flux constant. What we should do now? We need to demagnetize under excitation. Capacitive load alternators usually should do under excitation in order to perform the stable operation. Okay, after this we will go to the power flow equations. Then after we will see the actual operation, because once this fundamental structure is built up, parallel operation is nothing but a 5 minutes example. That is how I make the students comfortable. Questions come on the in the examinations directly on the parallel operation of alternators. If excitation is increased, what is the synchronous power? What is the load effect? How the load sharing? If mechanical input is varying, what is the effect? That question finally comes. But if I explain the question directly, they will forget immediately. So what I have started with: armature construction, phase, flux, armature reaction, voltage regulation, drops, different terminologies, power flow equations. Then if we start with this set of knowledge, actual operation, that analysis would become simpler. That is the purpose of explaining all these fundamentals theoretically at this level. Okay, let us take a quick break, then we will assemble here.
हेलो
The motors are provided. मोटर अच्छी मोटर कौन कर ना आपंकर एयर ता भर को आसो एयर प्रेशर थ्रू बिफोर ओपनिंग you have to ensure that the brake pads are in release condition. यदि लगी थी आप स्टार्ट करेंगे जमी आप भेहिकल ब्रेक लगिक अच्छे आप स्टार्ट कले कौन हम टायर खाई सिमिलरली हियर ब्रेक सब डैमेज ऑफ दिस रोटर टाइप आप देखो देखो तो आप जनरेटर को फिजिकली देखले बहुत देखो ये बड़ कर देखिए टे पड़ा कटि जो बड़े हाँ रोटर आप देखो रोटर ये हाइड्रो रे आप जानते स्पीड रोटर स्पीड हाइड्रो रे अधिक ना आपंकर थर्माल हाइड्रो रे अधिक थर्माल अधिक हाइड्रो रे कम कहीं
नंबर ऑफ पोल अधिकार
नंबर ऑफ पोल अधिकार नंबर ऑफ पोल अधिकार बोलिक आपंकर स्पीडटा कम है से आप पे पढ़े ये देखो ये पेरिफेरियल टाइटा एकोमोडेट द मोर नंबर ऑफ पोल्स द एक्सियल लेंथ रे देखो तो आपनकर कम
एक्सेल नो डायरेक्टर
है ना एक्सियल लेंथ रे कार अधिका थर्मल
एक्सेल ले थर्मल
अधिक काहे बिकॉज़ एदर 2 और 4 नंबर ऑफ पोल्स आर इक्वल तो एटा एटा आपनकर बेसी हबा आ दरकार नै क्या लेस नंबर ऑफ पोल कैन बी अकोमोडेट येट मोर नंबर ऑफ पोल्स आर अकोमोडेट दैट्स व्हाई एक्सियल लेंथ रा कम एटा आपनकर होची अधिक ये देखो ये कौन गोटे गोटे फुल ये आपंकर पोलटा कौन अच्छी आपंकर फिल हुए ऊपर गोटे ऊपर गोटे सीट 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 যেটা ওপেন করছিল রোড হ্যাঁ ଆପଣ ଦେଖନ୍ତୁ ଏଇ ଜାଗାରେ ବାସ୍ ହଁ ବାସ୍ ଏଇ ଦେଖନ୍ତୁ ଆପଣଙ୍କର ଏଇ ପଟ ଏଇ ପାର୍ଟ ପ୍ରଶ୍ନ ଦେଖନ୍ତୁ ଏଇ ଦେଖନ୍ତୁ ଆଉ ଟିକେ ଉପରକୁ ଉଠେ ଗୋଟେ ଛୋଟ କରୁଛ ହଁ ବାସ୍ ଏଇଠି ଦେଖନ୍ତୁ ଏଇଟା କପଲିଂ ହେଉଛି ହେଲା ରୋଟର ପାର୍ଟ ଦେଖୁଛନ୍ତି ଆପଣ ଯେଉଁ ବ୍ରେକ୍ ପ୍ୟାଡ୍ କଥା କହୁଥିଲା ସେ କୋଉଠି ଲାଗୁ ଦେଖନ୍ତୁ ଏଇ ପର୍ସନରେ ଲାଗୁଛି ଦେଖୁଛନ୍ତି ରିଙ୍ଗ ଭଳିଆ ହେଇଛି ରିଙ୍ଗ এই রিংরে আপনার ব্রেক প্যাড যে অছি 8-10টা 10-12টা যা রিং ব্রেক প্যাড ଅଛି না এই 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 যে এই রিংরে ସେମାନେ ଆସିକି ଟଚ୍ ହେଉଛନ୍ତି ଯେତେବେଳେ ଏୟାର ପ୍ରେସର ଯେତେବେଳେ ରିଲିଜ୍ କରାହେଉଛି in order to maintain the zero speed brake pad moves upward and come in contact with this surface of the rotor এই surface ହେଲେ ସେ zero speed maintain କରୁଛନ୍ତି before starting of the generator alternator you have to ensure that there should be release of the back pad otherwise ଆପଣଙ୍କର back pad ପୁରା ନଷ୍ଟ ହେଇଯିବ एक्साइटेशन तो सुधे एक्साइटेशन का फील्ड वाइंडिंग दिया होची फील्ड वाइंडिंग ता ପାଇଁ ଅଛି ଆପଣଙ୍କର
एक्साइटर
ଆଉ ଗୋଟେ ଜାଗା
शंट एक्साइटर
ଗଭର୍ଣ୍ଣର ଫଟୋ ଅଛି ସାର୍
ଗଭର୍ଣ୍ଣର କଇ ବେଶୀ ଏଇଠି ଦେଖନ୍ତୁ ଆଉ ଦେଖନ୍ତୁ ଏଇଟା ହଉଛି ଆପଣ ଦେଖନ୍ତୁ ଆପଣମାନେ ପଢ଼େଇଲା ବେଳେ ପିଲାଙ୍କୁ ନିଶ୍ଚିତ ଭାବରେ କହିଥିବେ ଯେ ଦ ଗ୍ୟାପ୍ ବିଟୱିନ୍ ସ୍ଟେଟର ଏଣ୍ଡ ରୋଟର वाइंडिंग इज वेरी लेस କାହିଁକି ନଟ୍ ଟୁ अवॉइड लिकेज ଆପଣ ପ୍ରାକ୍ଟିକାଲି ଦେଖନ୍ତୁ କେତେ एमएम
less than
ଆପଣ ଦେଖନ୍ତୁ ଆପଣଙ୍କ ଆର୍ମେଚର वाइंडिंग ପରେ ଆଉ ଗୋଟେ वाइंडिंग ଏଠି ଅଛି କି वाइंडिंग ଡାମ୍ପର वाइंडिंग ଆପଣ ଦେଖନ୍ତୁ ଆଉ ଦେଖो ରୋଟର ଆଉ ଷ୍ଟାର୍ଟର ଭିତରେ ଗ୍ୟାପ୍ ଇଜ ଭେରି ଲେସ୍ ଇନ୍ एमएम ଗଲା ହଁ ଏଇ ଦେଖନ୍ତୁ ଆପଣ ଏଇ ମାର୍କ କରନ୍ତୁ ଏଇଠି ହେଲା ଆପଣଙ୍କୁ ଦେଖନ୍ତୁ
डैम्पर
ଏଇଠୁ ଜମ୍ପର ଏଇଠୁ କନେକ୍ଟେଡ୍ ହେଇକି ଆପଣଙ୍କର ଗ୍ରିଡକୁ କନେକ୍ଟେଡ୍ ହେଇଛି 3 ଫେଜ୍ ଦେଖନ୍ତୁ 3 ଫେଜ୍ আপনি দেখুন যেটা মেইনটেনেন্স টাইমরে বাই চান্স সেটা ক্লোজ কন্ট্রাক্টরে আসিব তাকে পরমানেন্টলি তাকে রখা পারি করা হয়েছে তাহলে আপনার লোক যেতবে কাম করিয়া ছাড়ুচ্ছি ইউ টু এনশিওর দ্যাট পুরা সেফটি ইউ টু এনশিওর ଆଉ
सर ना
ନେକ୍ସଟ ଆଉ ଏଇଟା ଛାଡ଼ି ଆପଣ ହଁ ଠିକ୍ ଅଛି ସେଟା ଦେଖ ଏଇଟା ଦେଖନ୍ତୁ ଆପଣଙ୍କର ଆଉ ଗୋଟିଏ କଥା ଆପଣ ଚିନ୍ତା କରନ୍ତୁ ଆପଣ ଯେଉଁ କହୁଛନ୍ତି ଆପଣ ଫ୍ରିକ୍ୱେନ୍ସି ଆପଣ ଭୋଲ୍ଟେଜ ପାର୍ଟରେ କିଛି ଅସୁବିଧା ନାହିଁ କିନ୍ତୁ ଫ୍ରିକ୍ୱେନ୍ସି ପାର୍ଟଟାକୁ ଆପଣଙ୍କୁ ବହୁତ ଆନାଲିସିସ୍ କରିବାକୁ ପଡ଼ିବ ଆକ୍ଚୁଆଲି ଫ୍ରିକ୍ୱେନ୍ସି ଆପଣ ଫ୍ରିକ୍ୱେନ୍ସିଟା ଗୋଟେ କେଉଁଠୁ ଆଣୁଛି ନା ସ୍ପିଡ୍ ଫ୍ରିକ୍ୱେନ୍ସି ଆପଣ ଯେତେବେଳେ ଯେକୌଣସି କଣ୍ଟ୍ରୋଲରକୁ ସପ୍ଲାଏ ଦେବେ ଆପଣଙ୍କର ଗଭର୍ଣ୍ଣିଂ ସିଷ୍ଟମ୍ ଇଏ ଆପଣଙ୍କର ଭୋଲ୍ଟେଜ ରେଗୁଲେଟର ହଉ ଆପଣଙ୍କର ଗଭର୍ଣ୍ଣିଂ ସିଷ୍ଟମ୍ ରେଗୁଲେଟର ହଉ କୋଉ କ୍ୱାଣ୍ଟିଟି ଆପଣ ଦେବେ ଇଲେକ୍ଟ୍ରିକାଲ କ୍ୱାଣ୍ଟିଟି କରେଣ୍ଟ ମାନେ ଭୋଲ୍ଟେଜ କିନ୍ତୁ ଫ୍ରିକ୍ୱେନ୍ସିଟା କେମିତି ଦେବେ ଆପଣ କହୁଛନ୍ତି ରେଫରେନ୍ସ 50 ହର୍ଟ ମୋର ଯଦି 49 ହର୍ଟ ହେଲା ଦେନ୍ it will increase 1 hour କେମିତି କଣ୍ଟ୍ରୋଲର ସପ୍ଲାଇଟା କ'ଣ ଫ୍ରିକ୍ୱେନ୍ସିଟା ଆପଣ ୱାୟାର ପଠେଇଦେବେ
then actually exciter को तापरे
କଣ୍ଟ୍ରୋଲରକୁ ଆପଣ କ'ଣ ଦେବେ ଆପଣ ଯେଉଁ କଣ୍ଟ୍ରୋଲ ସିଷ୍ଟମ ନା ସିଗ୍ନାଲଟା କୋଉ ଫର୍ମରେ ଆପଣ ଆଣିବେ
error
କୋଉ ମାନେ ଆପଣ ସିଗ୍ନାଲଟା ମାନେ କ'ଣ
एनालॉग
କ୍ୱାଣ୍ଟିଟି ମାନେ ଇଲେକ୍ଟ୍ରିକାଲ କ୍ୱାଣ୍ଟିଟି ଆଣିବେ ନା
delta p
ମତେ ବହୁତ ଆପଣ ୱାୟାର କ'ଣ ସିମ୍ପଲ ପିଲା ସ୍ଟୁଡେଣ୍ଟ ଆପଣ ପଚାରିବା ଗୋଟେ ଡିଷ୍ଟାନ୍ସ ସାର୍ ଆପଣ
current
କଣ୍ଟ୍ରୋଲରକୁ ଆପଣ କ'ଣ ଦେବେ ୱାୟାର ଦେବେ ୱାୟାର ସାର୍ କ'ଣ ଫ୍ଲୋ କରିବ ଫ୍ରିକ୍ୱେନ୍ସି ଫ୍ଲୋ ହେବ କି
na signal
सर ये कंपेयर
current as well, if it is alternating, it
Transitive, sir.
voltage
signal.
Frequency is not a-
ମୋ କଥା ଆପଣ
Should convert
ଆପଣ ଭଲରେ ବୁଝନ୍ତୁ
ADC.
ମୁଁ ଷ୍ଟୁଡେଣ୍ଟ
Transitive, sir.
କ୍ୱେଶ୍ଚନ କରୁଛି ଆପଣ ଭୋଲ୍ଟେଜ ରେଗୁଲେଟର ଜାଣିଲେ ଠିକ ଅଛି ଆପଣ ଭୋଲ୍ଟେଜ ପାଉଛନ୍ତି ओके बट हियर इन फ्रीक्वेंसी लेट मैकेनिकल टर्म अब स्पीड टू फ्रीक्वेंसी को जुड़ा सेकंड्स पर सेकंड कंट्रोलर को कौन सिग्नल के पास पड़े
Temperatures.
केमिति पठे पुस्तक सोते आपण थ्योरेटिकल पिला को आपण पिला रियलाइज करिवे आपण आगे यदि खाली टर्म पे कहि दो ना इट इज नॉट सफिशिएंट फॉर द स्टूडेंट स्टूडेंट होते इंग्लिश जाके फील्ड हेड से जाके इंटरव्यू जो ना ताको पचारे हाउ टू मेजर द फ्रीक्वेंसी हाउ टू कंपेयर द फ्रीक्वेंसी आपण कोई सर गुटे आपरो फ्रीक्वेंसी 50 और 49 जो तो है इट विल बी कंपेयर
रेफरेंस बस सर
आपण पॉइंट बुझिले आपण जे कंट्रोलर को आपण सिंपल लेवल लैंग्वेज में ओआर जाइथो ओआर रे आपण स्पीड टा को केमिति पठेबो केमिति ओआर स्पीड टा मेजरमेंट है सर aqua generator voltage
Yes, sir.
that means your speed will be converted in form of the voltage that voltage represents the speed that voltage represents the frequency example suppose you can take 0.8 volt is your 1 hertz frequency बुझिले आपण देखबे एतिकी स्पीड रे केते वोल्टेज जनरेट होती सेति वोल्टेज डिवाइड बाय स्पीड है आपण दैट में होते माने स्पीड केते वोल्टेज रे केते फ्रीक्वेंसी और सही क्वेश्चन पिला आपन ए क्वेश्चन पचारियो
सेटा समझे पर यूनिट रे कन्वर्टिंग की थिबो
आपण पिला सिंपल लैंग्वेज आपण बुझाइबे सी को सर कंट्रोलर को वायर जीवो वायर रे केमिति फ्रीक्वेंसी सर को पठाइबी पिला एति के आपण पचारियो आपण केबे भी पिला को माने बेसी आपण टेक्निकल लैंग्वेज कहिबेनी आपण एमिति कहिबे से थोड़ा कर आपण कथा बुझियो जोटा सर कहिए एक्वा जनरेटर you to measure the speed in terms of voltage and you can compare that voltage so that voltage represents the frequency बुझिबे ना नहीं सिस्टम आपको पचाली कंपेयर का केमिति हो पिला आपको के क्वेश्चन पचारियो सा स्पीड ता केमिति कंट्रोलर को पठाइबी तो बडी द सॉल्यूशन ओके को पठाइ क्वेश्चन पचारियो आपको इतनी आपण दिस आर द आपको कहे परमानेंट मैग्नेट जनरेटर बस सामने टैको जनरेटर परमानेंट मैग्नेट जनरेटर आर इंस्टॉल ऑन द आपण जो अल्टरनेटर्स ये अल्टरनेटर ऊपर अल्टरनेटर जो होची तार ऊपर एक परमानेंट मैग्नेट जनरेटर तार इंस्टॉल कराई है only reasoning only to sense the speed in terms of voltage and that voltage is taken to the governing system. अपन रेफरेंस तो दबे 50 hertz का कहते voltage actual voltage will sense by this permanent generator as per the rotation of the rotor सेतु अपन कोन हो एरर सिग्नल जो करंट डेवलप हो that current will go to the transistor and transistor will move upward or downward accordingly जाओ
Next.
आपण देखो जे केमिति एक्चुअली ऑपरेशन ता सेठी हो इडा आपण टाको जनरेटर केना आपण पिला ये क्वेश्चन ता पचरी पारे वोल्टेज रेगुलेटर पिला को डाउट रहिबनी किंतु गवर्निंग सिस्टम पार्ट रे डाउट रहबो केना गवर्निंग सिस्टम मेनली फिजिकल क्वांटिटी मैकेनिकल सिस्टम काकू आपण केमिति रेगुलेटर को नबे केमिति क्वांटिटी ता नबे इतना गुडे ए देखो ठीक है तो ए जो ऊपर डाक्स देखछंती ये ऊपर এই পার্ট দেখুন এই পার্ট হলে আপনাদের দেখুন এটি রহি জেনারেটর সিরিজ हाँ ये जनरेटर रही देखो तो जनरेटर ऑलरेडी रही है ये ऊपर ये डाला अपन को टैको जनरेटर ठीक है तार वाइंडिंग ता ऐसे देखो दे जाएगा तापर दल तारो चलो हाँ এইটা হচ্ছে আপনাদের রনার ये কাহাকো আপনাদের টিকে তଳ কষে
Water flow.
তଳ তଳ টিকে তଳ কর তଳକୁ ଟିକେ ଖସି ପାରିବେ ଦେଖିଲା ହଁ ଆଉ ଟିକେ ଠିକ ଅଛି ଉପରୁ ଉଠା ଆପଣ ଦେଖନ୍ତୁ ଏଇଟା ଏଇଠି ଦେଖନ୍ତୁ ଏଇ ପର୍ସନଟା ଏଇଟା କପଲିଂ ହବ କୋଉଠି ଏଠି ଯା କୋଉଠି ଗଲେ ରୋଟରକୁ ଯା ଖାଲି ରୋଟର କୁ ଯା ଖାଲି ରୋଟର ହଁ ବାସ୍ ଦେଖନ୍ତୁ ଏଇ ଦେଖନ୍ତୁ ଏଇଟା ହେଲା ରୋଟର ତାକୁ କନେକ୍ଟେଡ ହେଇଛି ରନର
Hub. Runner hub.
ହେଲା ରନର ଆପଣଙ୍କର ଯଦି ଆପଣ କହୁଛନ୍ତି ଟର୍ବାଇନ ସିଷ୍ଟମ ଇନକ୍ଲୁଡ୍ସ guiding system and the runner system. Guiding system is the system which regulates the flow of input to the turbine. It may be steam or water. A runner system in which the steam or water is injected. Total that is turbine system. Not turbine only would be total is your turbine system. এইটা ଆପଣ ଦେଖନ୍ତୁ এইଟା ହେଲା ଆପଣଙ୍କର ଗାଇଡିଂ ସିଷ୍ଟମ ଏଇ ସବୁ ଗୋଟେ ଗୋଟେ ହେଲା କହନ୍ତି ଗାଇଡ ବ୍ୟାନ୍ ଓ ୱିକେଟ୍ ଗେଟ୍ ଆପଣମାନେ ପାୱାର ଷ୍ଟେସନ ଇଞ୍ଜିନିୟରିଂ ପଢଉଥିବେ ଏଇଟା ହେଲା ହଉଛି ଆପଣଙ୍କର ୱିକେଟ୍ ଗେଟ୍ ଆଉ ଗାଇଡ ବ୍ୟାନ୍ ଏଇଟା ଆକ୍ଚୁଆଲି ଏଇ ଯୋଉ ପାର୍କ ଦେଖୁନାହାନ୍ତି ଦିଟା ଗାଇଡ ବ୍ୟାନ୍ ଭିତରେ ଯୋଉ ପାର୍କ ଦେଖୁଛନ୍ତି ଏଇ ପାର୍କ ଭିତରେ ଆପଣଙ୍କର ୱାଟର ଫ୍ଲୋ ହେଉଛି ଆପଣ ଜାଣିଥିବେ ଯେ ଟୁ ଟାଇପ୍ ଅଫ୍ ଗଭର୍ଣ୍ଣିଂ ସିଷ୍ଟମ ଗୋଟେ ହେଲା କ'ଣ ଗୋଟେ ନୋଜଲ ବେସ୍ ଗଭର୍ଣ୍ଣିଂ ସିଷ୍ଟମ ଆଉ ଗୋଟେ ହେଲା ଥ୍ରୁ ଆଉଟ୍ ମାନେ ଅଲ୍ ସାଇଡ୍ସ ରୁ ଫ୍ଲୋ ଟୁ ଟାଇପ୍ସ ଏଠି ହେଉଛି କ'ଣ ଆପଣଙ୍କର ନୋଜଲ ବେସ୍ ମାନେ 3-4ଟା ପଏଣ୍ଟରେ ଆପଣଙ୍କର ଇଞ୍ଜେକ୍ଟ ହେଉଥିବ ୱାଟର ଏଟା ହେଲା କ'ଣ ଅଲ୍ ସାଇଡ୍ସ ରୁ ୱାଟର ହେଉଛି ଇଞ୍ଜେକ୍ଟ ହେଉଛି ଆଉ steam or water injected on the runner ଆପଣ ଦେଖୁଛନ୍ତି ଏଇଟା ଏଇ ଯୋଉ ଆପଣ ଏଗୁଡ଼ା ଦେଖୁନାହାନ୍ତି ଇଏ ସବୁ ଗୋଟେ ରିଙ୍ଗ କୁ କନେକ୍ଟେଡ ତାକା ଆପଣଙ୍କ ଗଭର୍ଣ୍ଣିଂ ସିଷ୍ଟମ ସେ କ'ଣ କରିବ ଆପଣଙ୍କର ରିଙ୍ଗ ତାକୁ ବୁଲେଇବ ଯଦି ଆପଣଙ୍କର ଏମିତି ଦେଲା ଓପନିଂ ଏମିତି ଦେବ କ୍ଲୋଜିଂ এইগুড়াক ସବୁ ଦେଖନ୍ତୁ এইগুড়াক ଦେଖନ୍ତୁ ଏଗୁଡ଼ାକ ସବୁ ସେଇ ରିଙ୍ଗ କୁ କନେକ୍ଟେଡ এই দুইটা পাথরে ক্লোজিং মানে কোন হবে ইয়ে এଠି লাগিଯିବ ইয়ে এଠି লাগিଯିବ ইয়ে এଠି লাগিଯିବ ই লাগিଯିବ ସବୁ ଆଠଟା ଭିତରକୁ ଆସିପାରିବ 100% ଓପନିଂ ମାନେ ଇଏ ପୁରା 90 ଡିଗ୍ରୀ ଇଏ ଏମିତି ସିଧା ହେଇଯିବ ପୁରା ଓପନ ହେଇଗଲା accordingly ଆପଣ 20% କ୍ଲୋଜିଂ 30% 20% ଓପନିଂ 30% ଓପନିଂ ଆପଣଙ୍କ ସେମିତି ସବୁ এইটি ধর আছে আপনার ক্লোজ পোর্শন রাইট 20% ওপেনিং মানে টিকে ওপেন হইতো তারপরে আউট টিকে পুরা হেড 100% ওপেন
सर लगे
চাষরা উপরে ক্লোজ কেমতি মানল কি
দেখি বুঝি পাচ্ছেন তো আপনার এটা ইন্ডিভিজুয়াল आपको मतलब विकेट गेट और गाइड वेल
कितने
ये जो ଗୋଟେ ring को कनेक्टेड होता है ऑल द गाइड वेल्स को कहते हैं गाइडिंग रिंग
आपके असिस्टेंट सेट
एंड गवर्निंग सिस्टम एक गाइडिंग रिंग को control करे to regulate the water inflow or steam inflow to the turbine
सही कोड
आप कितने वाटर दवा को चाहो जी
देखाय समझ
पूरा आपण एक से रेगुलेट करी से रिंग को बुलेगे रिंग को बदले वो रिंग अपन 10% ओपनिंग करे सबरा 10% ओपनिंग हो 20% ओपनिंग हो सबरा 20% ओपनिंग हो क्लोजिंग करे सबरा क्लोजिंग हो एमती हो नेक्स्ट जो रिंग टा देखा आपण हां एटा आपण ता रिंग देखंतु ए लागि देखंतु एइथरे सब सुधार सब
हम छाटी पड़े
बस ऊपर लागियो देखुछंती 1 2 3 4 5 6 7 8 9 10 11 12 13 14
2013 में की
15 16
लगा
सो पूरा आपण गाइड अछि देखो
सेम से केस रे से जेल पकड़ छाड़ी गस
एइथरे सब ता ऊपर लागियो एइटा कुछ मोमेंट
नाम की जांच जेल भीतर सेठी कोड बस
चिंता करନ୍ତୁ ଆପଣଙ୍କର କଣ୍ଟ୍ରୋଲ ସିଗ୍ନାଲ ଭୋଲ୍ଟେଜ ତା କରେଣ୍ଟ ଆଉ ବୁଲେଇବେ ବୁଲେଇବେ ଆପଣ ମୋଟର ଆକୁ ବୁଲେଇବେ ଆପଣ ସପ୍ଲାଏ କରେଣ୍ଟ ଦେଇଦେବେ ମୋଟରକୁ ଯେଟା କି ଆମର ଫିଲ୍ କରେଣ୍ଟ ଆପଣ କରୁଛନ୍ତି ମୋଟର ଦେଇଦେବେ ଫିଲ୍ କରେଣ୍ଟ ଅଛି ଚାର୍ଜ କରିଦେବ ଇଜିଲି ଆପଣ एक्सटेंशन सिस्टम इट इज इजी टू चेंज द फील्ड करंट बट हियर आपण एटा को बुलेया पई आपण हाथ कोन दरकार
हाइड्रोलिक
बुझि पड़तो ना काई तरी काहे की को टाइप रो फोर्स एटी अप्लाई करा होची कैन यू यूज मोटर हियर और मास केते तो आपण मोटर को देई की मोटर आकू ड्राइव कर परिबो ताको एटू हाइड्रोलिक प्रेशर दिया ऑयल प्रेशर दिया तेणु आपको मेसीन ले तुम आपन खाली करी पावर जनरेशन टू इंडस्ट्रियल ड्राइव्स पावर स्टेशन ले विदाउट इलेक्ट्रिक मोटर इलेक्ट्रिक मशीन्स ताकि इलेक्ट्रिक मोटर मध्ये एसेंशियल कना गुटे मोटर अछि जे कि ऑयल प्रेशर यूनिट गुटे अछि ओपीयू इट मेंटेन द 40 kg प्रेशर इन नेगल हेड पावर स्टेशन इट मेंटेन ऑलवेज 40 kg प्रेशर फॉर 37 टू 40 kg प्रेशर से तो 37 प्रेशर हे जिवो ऑटोमेटिकली पुनी मोटर चलिवो 40 kg प्रेशर क्रिएट करिवो सेति की प्रेशर सबले से मेंटेन कर रखिवो काई ना ऑयल प्रेशर रे आकु से ओपनिंग क्लोजिंग हो ना सेति कदी प्रेशर डेवलप न हो यू कैन नॉट ओपन और क्लोज एटा तमे हमें एटा को क्लोजिंग ओपनिंग करि परिबे आकु क्लोजिंग ओपनिंग करिया पई तो 30 प्रेशर रिक्वायरमेंट इज 30 टू 40
एसी ऑन करतो
so motor is placed ताकू कोई ओपीयू मोटर to maintain that concept of pressure अपन रनर देखो अपन एटा ना अपन एटा रनर हब एटा के रनर ब्लेड रनर कंसिस्टिंग ऑफ रनर हब एटा रनर हब देखंतु एटा रनर ब्लेड हमरा कंट्रोल रूम देखिबे हला जोटा अपन लोड एंगल बोलली कंट्रोल रूम देखिबे अपन रनर एंगल गुटे मते अपन देखिबे मीटर थाई एटी रनर एटी अपन आर डिजाइन टा एटी देखंतु आपन वाटर टा इंजेक्ट आबो कोठी आपन ये जाय इंजेक्ट हो इंजेक्ट ले वाटर विल इमीडिएटली कम टू द डाउन देखो सेंटी डिजाइन है आपन रनर हब टा को आपन देखो एला काई किंतु डिजाइन करा आपन वाटर एते आसु वाटर एते आप एते इंजेक्ट हो ये कौन हो गोटे साइड को मूवमेंट करियो सही ना आपण केसिंग ता जो होईची केसिंग ता जो होईची जे रनर अछि एंड सेटले आपण लाइनर केसिंग होईची से केसिंग कोन हो तई मारो ए जे हला ए मारो एटी चांस अछि कोन माने गोटे साइड टिल्ट हो चांस अछि अनस्टेबल हो चांस अछि सेहि पई हियर counter weight is given so runner of देखो the counter weight is given so that how unstable over balancing से होता है इसमें याकू
एटा नो एटा आईएफपी से
और काउंटर वेट
नहीं एटा
रनर ब्लेड बैक अपन देखो तो देखि ए ब्लेड बैक अपन पड़ी दिबे फिक्स ब्लेड और मूविंग ब्लेड रनर ब्लेड एज अ फिक्स ब्लेड और मूविंग ब्लेड आ किछि ब्लेड फिक्स कर परबे किछि ब्लेड मूविंग कर और बोथ पर और ओनली फिक्स ब्लेड or moving plate. ମୁଁ ଆପଣଙ୍କୁ ଏଇଟା କାହିଁକି ଦେଖେଇଲି ଯେ ଆପଣ ଆକ୍ଚୁଆଲି ଫିଲ୍ଡରେ ଆର୍ମେଚରର ଷ୍ଟ୍ରକ୍ଚରଟା କେମିତି, ରୋଟର ଆପଣଙ୍କର ଷ୍ଟ୍ରକ୍ଚରଟା କେମିତି, ଆଉ ଯେଉଁଟା ଆପଣ ଫ୍ରିକ୍ୱେନ୍ସି ଯେଉଁ ଜିନିଷଟା ଆପଣ କହୁଛନ୍ତି ହାଉ ଇଟ୍ ଇଜ୍ ରିଲେଟେଡ୍, ଆଉ କ'ଣଟାକୁ ଆପଣ ଅପରେସନ୍ କରୁଛନ୍ତି, ତାର ମାନେ ୱେଟ୍ କେତେ, ଯେଉଁଟାକି ଆପଣଙ୍କୁ ଗୋଟେ ନିଜେ ଗୋଟେ ଫିଲ୍ କରିପାରିବେ।
So if you take the per phase equivalent circuit of a 3-phase alternator, so we are representing the generated EMF E at an angle delta. From the equivalent phasor diagram, as we have seen, there exists an angle phase difference between terminal reference voltage and E, no load generated EMF is delta. So E at an angle delta with an impedance drop, synchronous impedance drop, terminal voltage V at an angle 0. So from this equivalent circuit, okay. From this equivalent circuit, if we write the KVL and derive the expressions for power, then we will get two terms, P and Q, active power and reactive power. Derived form, it is V into IA star. Again, we may have a simple clarification. So it is to define the correct phase angle between V and IA. Otherwise, with respect to reference, if we take current is negative and voltage is positive, say E at an angle delta we are discussing, right? If current is also varying, the actual phase difference between V and IA would be obtained correctly if we take IA star only. For example, say this is the reference, say V at an angle 10 and I at an angle minus 20. What is the actual phase angle between V and IA? Actually, V is with respect to reference, say 10 degrees and I is minus 20 degrees. Okay, with respect to reference. But what is the actual angle between V and I?
30 degrees.
30 degrees. It should be 30 degrees. If you do not take this IA conjugate, what is now theoretically the phase difference between V and IA? Now 10 minus 20 minus 10, but it is actually not in the case. So that is why VIA star. One simple way to understand, make students understand why VI conjugate is the complex power. Right. So that is why VIA star. Upon deriving that, we get EV by ZS into cos theta. Theta is the impedance angle minus delta minus V square by ZS cos theta, and Q is the reactive power. If we neglect armature resistance compared to synchronous reactance, then that ZS will become QXS. So this would be the final active power and reactive power expressions of three-phase alternator. In case of salient core alternator, we can derive the same expressions for active power as well as reactive power for salient core alternator as this. This active power, if you consider, this active power upon derivation gets two terms, EV by XD. Now, in case of salient core, there are two reactance concept. I think yesterday we discussed it, right? So two direct axis and quadrature axis reactance. So that direct axis reactance component associated active power is what we call as electromagnetic power, and the other component is now called reluctance power. Even though excitation is not available for salient pole machines, they still develop some power that is called reluctance power. So, if you observe, both in case of cylindrical rotor and salient pole machine, P power E is now associated with delta. P associated with delta with a sign relation. P and sin delta. If we plot a graph from of P with respect to delta, it is sinusoid. So the power angle. So that gives power angle relation, and there is a condition of maximum power derivation. If you derive the P active power output with respect to load angle dP by d delta and make it 0, we will get a condition called load angle must be equal to the theta, right? Then we will get the maximum power condition. How maximum power output can be delivered? This is required for the analysis of parallel operation. If we change excitation and if we change the input, mechanical power input to the alternators, how the powers are getting balanced. So synchronous power or synchronizing power coefficient will come into picture when any external disturbance occurs either at the prime mover side or the load side or at the excitation side. Major disturbances can occur here. Then synchronizing power will come into picture to try to stabilize these alternators to operate in parallel. That is why synchronizing power is now directly associated with stability. We discussed that is why earlier we introduced it. The stability is directly now proportional to this synchronizing power only. Particularly in case of parallel operation, we need to theoretically first fix this stability is ensured. Stability ensured, so active power angle curve gives the sinusoidal relation. So this is during the generator mode. Synchronous machine, just like DC machine, DC generator, once we completely know about that, motor is analogous. May not be similar, but analogous. We can relate. Similarly, synchronous generators, if we know, synchronous motors would be analogous of synchronous generator analysis. So generator part, let us focus as of now. So that is the sinusoidal relation when delta is varying sinusoidally, that P varies. Then synchronizing power coefficient, as initially we discussed, is the rate of change of synchronous power with respect to delta. So this shows the region of operation. So delta must be less than 90 to operate the machine stable. So this is the stable region. When it delta load angle is increasing beyond 90, machine goes unstable. Unstable, which is not required. We want stable operation under parallel connection of alternators. And this is the salient pole alternator power angle relation for both generator mode as well as motoring mode. Motoring mode, let us give it aside, and generator mode, we are splitting this total power angle curve into splitting of electromagnetic power component plus the reluctance power component, and the components are derived by the equivalent circuit from the cylindrical rotor type as well as phasor diagram of salient pole three-phase alternator type. We can derive them. So this is a stable operating region condition to satisfy, which is required for the parallel operation of alternator. Right. Whenever any disturbance occurs, if any disturbance occurs, this load angle disturbs. When this load angle disturbs, then synchronizing power. Synchronizing power is caused nothing but synchronizing current. By means of synchronizing current, now it will try to adjust. How? Demagnetizing and purely magnetizing. Say that we will discuss once after the connection, actual connection of the alternators, how the machine will balance. One voltage increases, one generator voltage if it is increases by means of excitation voltage. Set voltage will increase as a resultant.
The synchronizing power is auto generator.
Auto generator. Usually auto generator. To make it as per our requirement, we need to adjust the increased or decreased parameters for the stable level. Those parameters are inherently happening with this by operating the machines in stable region. So the expressions are given from this expression. Okay, synchronizing power coefficient with respect to delta, the derivation is now given by this expression. And the plots, relative plots are given in this way. After having this brief synchronizing torque, once we know the synchronizing power, earlier we discussed from the armature flux, armature field and main field. So when they are having interaction, when they are happening at a time, there exists a term called synchronizing torque, electromagnetic torque it got introduced, right? That electromagnetic torque which acts opposite, just now sir has discussed practically how that actually happens, which opposingly acts towards the prime mover torque, that torque, right? So associated with this synchronizing power is that synchronizing torque, just power by speed, torque into speed will give us the power. So synchronizing power, synchronizing torque into speed. So this is synchronizing power. We got divided by the speed, it will give us the synchronizing torque. Theoretically, this is the definition of synchronizing torque. Okay, parallel operation. Now, as each is now familiar. Now, in order to operate the alternators in parallel, the main important and must conditions to satisfy are terminal voltages must be constant, frequency must be constant, phase sequences also must be constant. Terminal voltages, how can we assure that voltages are constant? By means of voltage measurement methods, any multimeter or any voltage measuring instrument, we can say magnitudes are equal first. Next, frequency just now we discussed, right, how to make the frequency. Okay, in order to have this frequency, and phase sequences also must be maintained constant. Together making this operation happen simultaneously, we use certain standard methods. One example I will just briefly show here is a dark lamp method. 3 lamps you connect between R phases or similar phases of both existing and incoming machines. Then you observe the flickering of the lamps. First we should understand why the lamps flicker. Unless you give a difference potential across the lamp, it will not flicker. If there is an equal potential from that side, 2 terminals, right? If you take a single bulb, if there exists a potential difference, then voltage, current flows, so bulb glows. If the phase difference is not there, that side also same phase and this side also same phase, bulbs do not glow. These can happen in 2 ways, magnitude difference as well as phase difference also. Say bulb one side is now connected, bulb one side is connected, say R phase of one side. Bulb another side is now connected, R phase of the alternator. Now, if magnitudes are different, definitely potential difference exists, so bulbs glow. If phase is different, magnitude same, then what will happen? Will they glow or not glow? They glow. Phase difference exists, that means they glow, because Vm sin omega t plus Vm sin omega t minus 120 is not 0. Phasor they are giving line voltage. So you are applying a line voltage across the bulb, definitely it glows. If frequency is now differing, then how the bulb glows? For 50 Hz frequency, individually if you connect the bulb, practically I am explaining what I observed in the laboratory experiment. The bulb glows usually of an alternative supply, single phase, 50 times per second. Say, bulb is glowing and bulb is shutting off. Then this flickering rate happens because sinusoidal supply will be 50 times per second. It goes from 0, maximum 0, negative maximum and all. So bulb also glows accordingly with its sinusoidal supply and goes maximum 0, again maximum. This flickering, this rate of the change of brightness in associated with sinusoidal supply also varies sinusoidally with 50 times per second. But with our human naked eye, we cannot observe this practically. If it is 2 Hz per second, say, then bulb will go off and on, that means brightness to darkness 2 times per second, that we can observe. If there exists a frequency difference between the existing alternator or say infinite bus bar or incoming alternator, frequency difference, then the difference of this frequency will cause the bulb to flicker within the same rate, which is we called as relative frequency, beat frequency. Say 50 Hz is the standard incoming alternator, we have to adjust the frequency in order to connect it in parallel with 50 only. Suppose we are managing, we are now running the alternator with 48 or 45. Relative 50 minus 10 is 45, 5. With 5 beat frequencies per second, this bulb will start glow and simultaneously bright, simultaneously go dark. Right? Then, by what means can we change the frequency? Input, prime mover, NS, right? Then we change this incoming alternator frequency such that beat frequency should become 0. When there is no frequency difference, bulb will almost will never flicker. Almost will never flicker. It means for no difference. Then bulb will go to dark position. That means synchronization is closely achieved. Practically, if you say closely, theoretically, ideally, we say synchronization is achieved. At that moment, when all lamps are in dark position, we close the switch. That is the experimental way of synchronizing, conventional way. In the laboratory experimental demonstration in the upcoming session, I will show you. Just you all know that. We will just observe how this synchronization happens. So by following these synchronization methods, then we connect the alternators in parallel. And there are other methods are also. For time being sake, we are not going to cover the conventional topics. Rather, we will see the theoretical calculation and analysis, like two lamp method, synchronoscope method. These are the standard procedures to make the synchronization happen. So, this is a phasor relationship of existing system and the incoming system to make sure that they are running or rotating with the same phase, same magnitude and the same frequency also. So, if you connect the lamp here, if there exists a difference between R phases of both incoming and the existing, so lamp will flicker according to the difference. For that, showing that in pictorial way, it has been demonstrated here. So, if the synchronoscope, as sir explained and we are aware of this, whether the frequency of incoming alternator is higher than the existing or lesser than the existing, synchronoscope will detect the process of synchronization. This is the latest method now employed everywhere, both at the laboratory side as well as the industrial side. Synchronoscope method is more popular than the conventional. Now, after the synchronization, now two alternators are connected in parallel. Now, on no load, if some disturbance happens, primarily, generally, alternators can have two types of variations. One is at the excitation level. If the excitation varies, as per the EMF equation, EMF generated will be varied.
I think this is the second section.
Yes, sir. Second session. So, if the prime mover input also can be varied. So, then how these two alternators will get stabilization? How synchronizing power will come into picture? How synchronizing current will make these two systems stable? We will see in the next session after the lunch.
Any questions? Any discussion?
Sir, one thing, what is the significance of the reactive power? That one part hour is the active power.
Yes, sir.
Another part is the reactive power.
The reactive power, the synchronizing power can be active power or can be reactive power. Synchronizing power, in order to make the alternators stable, whenever the disturbance occurs, either at the effect of change in excitation or in the prime mover, synchronizing power need not to be always active power. Synchronizing that derivation is there in this analysis only, that I am going to cover in the afternoon session.
Sir, what is the angle? What is the particular angle at which we get maximum synchronizing power?
0 to maximum particular
angle. There is a cos delta term coming into picture. So moto.
ideally that should be 0 if we say but practically it does not. It should be from 0 to 90.
90. But 90 is also in practice.
Is not.
0 is
So
also
closely industries are what I got
35,
studied.
Is it 35 degree?
Yes, 20 to
35 degree.
yes to 20 to 35 degrees is the optimum level they maintain. Yes.
What is the significance of reactive power?
Electric power
What
is the current.
is the significance of reactive power? Good question. The active power do all the work. Reactive power is
That maintains the voltage.
It maintains the flux.
what is the need of reactive power? So active power हम सब काम करते हैं. Reactive power हम सब काम करते हैं. Come a simple example. Take the example of a transformer. आपन ट्रांसफॉर्मर रे प्राइमरी वाइंडिंग सेकेंडरी वाइंडिंग active power is transferring from primary winding to secondary winding. VA in primary winding, VA of secondary winding is same.
No.
Same na nahi? VP IP equal to VS IS. So that KVA rating, VA rating of the output is same. पर ऐसे ठीक है अपना तो reactive power आवश्यक है.
Point.
Magnetic
Flux.
It helps to transfer power from one winding to another winding. Or it will help in case of induction motor. कौन बोल?
Mutual induction process is
हाँ?
transfer.
ट्रांसफर वगैरह से हेल्प करो. इंडक्शन मोटर अपन देखो रिएक्टिव पावर अपन जोठी भी अपन मोटर देखो तो अपन रिएक्टिव पावर के कंज्यूम करछि इंडक्टिव लोड
Inductive load.
we consume the reactive power. Inductive load or capacitive load? Capacitive load provide reactive power, inductive load consume reactive power. And active load अपन तो resistive load ये तो reactive power किस consume करो ये दिन नहीं अपन reactive power consume करो अब maximum you will find 99% of loads are inductive in nature 99% loads अब जो भी अपन इंडक्टिव माने पावर कंजम्पशन होची देखिए सबुआडे अपन मार्क करिवे दैट फैसिलिटेट ट्रांसफर ऑफ पावर एक्टिव पावर वन पार्ट पे नतर अपन ट्रांसफार्मर देखंतु इंडक्शन मोटर देखंतु से ही ट्रांसफर करिया ही रिएक्टिव पावर हमके हेल्प करू
Actually, reactive loss not होय. Reactive loss तो बल्कि बड़े कैपेसिटर और इंडक्टर को जाए, इंडक्टर और कैपेसिटर को पड़े ऐसे. It swings between these two elements.
रिएक्टिव पावर लॉस होत रिएक्टिव पावर लॉस काई होत आपण देखंतु दीटा कंपोनेंट आपण एटा करंट कोजंती दीटा एक्टर कंपोनेंट वोल्टेज कोजंती एक्टिव वोल्टेज रिएक्टिव वोल्टेज एति आपण करंट मतलब एक्टिव करंट रिएक्टिव करंट दीटा कंपोनेंट आपण कोजंती ना तो फेजर फॉर्म रे आपण लेखुचंती करंटटा दीटा कंपोनेंट अछि दीटा कंपोनेंट अछि किंतु आपण रिएक्टिव लॉसेस ताकू आपण काहेकि ताकू एटा इफेक्टिवली आपण नौ नाती जेरे कि आपण माने जत सपोज आपण कोजंती देखंतु आपण कोजंती मेगावाट केते पावर आपण जाउ मेगावाट किंतु आपण से पार्ट ताकू कोना मेगावाट ताकू आपण कोना किंतु मेगावाट जदि नथांदा दरकार नथांदा आमे काहेकि जो जनरेटरटा डिजाइन करूछु सेठी काहे व्हाई विल वरीड अबाउट द आपनकर वोल्टेज पार्ट वोल्टेज रिएक्टिव पावर रिएक्टर आपन जोटा वोल्टेज रेगुलेटर आवश्यकता कोन दुई दीटा में जल्दी आवश्यकता है हम वोल्टेज मेंटेन करछे जे एक्टिव पावर पाई रिक्वायरमेंट ऑल्सो रिएक्टिव पावर पाई मध्ये रिक्वायरमेंट ना वोल्टेज का मतलब दीटा कंपोनेंट ही जाउ जेते आपण लोड दो जल्दी लोड करंट कोन होउची यदि लोड हैविंग बोथ रेजिस्टेंस इंडक्टेंस अछि से लोड करंट रो नेचर टा कोन आपण कोन होते दीटा रहिला तो वोल्टेज टा दीटा रहयो है दिटा वोल्टेज तो रहिबो ना एक्टिव कंपोनेंट रिएक्टिव कंपोनेंट एक्टिव पावर जो एक्टिव वोल्टेज को नहीं कि एक्टिव करंट को नहीं कि एक्टिव पावर रिएक्टिव वोल्टेज रिएक्टिव करंट को नहीं कि रिएक्टिव पावर रे कंपोनेंट रहिबो तो रिएक्टिव पावर रिक्वायरमेंट और कि आपण जति की लोड अछि रिएक्टिव लोड अछि जति रिएक्टिव पावर रिक्वायरमेंट करछथि जदि हम जनरेटिव नॉट जनरेटर जो इंस्टॉल हेछि इट नॉट माने सफिशिएंट the capacity 9 to provide that much of reactive power needed by the reactive load. I mean, additional capacitors we are installing at the grid level. Grid level, we are going for issuing the additional reactive compensating devices like the your capacitor upon phone. हाँ, reactive power generate for যদি requirement नथा कहीं हमें generate कहीं करूँ যদি আমরা যে সোর্সেস যেটি সোর্সেস আছে সেখানে যদি সাফিসিয়েন্টলি যদি প্রোভাইড করতে পারতাম তাহলে সেটি তোমার নেসেসিটি নাই তো রিঅ্যাক্টিভ পাওয়ার সিগনিফিকেন্স হলা ইট হেল্পস ফর ফ্যাসিলিটেট ট্রান্সফার অফ অ্যাক্টিভ পাওয়ার ফ্রম ওয়ান পার্ট টু अनदर তাকু जोटी अब सेठी हमको रिएक्टिव पावर एसेंशियल अछि आपण रिएक्टिव पावर नथिबा आपण ट्रांसफॉर्मर रे कोन हो ट्रांसफर हे करियो पावर इंडक्शन मोटर रे हे करियो कि आपण जो घरे जो लोग होते आपण जो ट्यूब लाइट जो चोक यूज करछोले एडी ट्रांसफर हे करियो कि आपण फैन जो घरे यूज करछोले सेठी चालियो कि किछि भाई
But sir, reactive power flow by voltage gradient तक है. It will flow from higher voltage towards lower voltage. But active power can flow reversely also. From lower voltage to higher voltage, it can flow provided that the angle delta is more. If the angle delta is more, it can flow reversely.
In synchronous motor, that is why that application in order to have the reactive compensation, we use synchronous motor for under overexcited condition, reactive power flows into the grid. That's what the case you are in. Yes, it happens. That is why we use as a compensation. In the line, as you were telling that reactive power flow from higher to lower. Right? But in order to maintain that constant, we will compensate by means of synchronous condenser for under overexcited. Overexcited synchronous machines are used.
Sometimes fax devices can be used.
We have this reactors. Line reactors are there. Nowadays, all electronic converter custom power devices are also there with voltage reached or step com.
Semantics question କରୁଛନ୍ତି आंसर विदाउट माइक दे दो भलसे रेकॉर्ड होछ
All these are no.
ना ना तो भरो जी सर सब दी पड़े दियो
इन्वर्टर पर कोन करछो
हां जल्दी पड़े
एसी खाली एसी माने एसी एक्टिवेट रिएक्टिव बहुत ना आपण घरे तो एक्टिवेट रिएक्टिव लोड अछि सेठी यदि इन्वर्टर यदि एक्टिवेट रिएक्टिव लोड न करियो ताले केमि आपण घरे तो रिएक्टिव लोड कालियो आपण तो इनेला डीसी ना ओला जो तो आसा इन डीसी इन्वर्टर में कन्वर्ट करछि
ये
एक्टिवेट रिएक्टिव যদি অ্যাক্টিভ ইকুয়ালি জেনারেট করে কোন হবে আপনাদের খালি অ্যাক্টিভ পাইবে যেতিকি হবো আপনাদের অ্যাক্টিভ রিঅ্যাক্টিভ হলে অ্যাক্টিভ পাওয়ারটা কমে যাবে না কমে যাবে কেন যার ইনপুট ডিসি after losses in the inverter then output with the then there will be shared by the active power and the reactive power.
But we are paying time for generating reactive power.
Yes, because reactive power was responsible to maintain the voltage.
It is started in the line.
Yes,
So we are
the
paying time.
arbitrary linked with the reactive power.
The power will be less than 40.
Yeah, around 32, 40 degrees. Yeah, I wrote this. I got it. I got it. It's not 20. It's around 32 to 40.
That is, you are responsible for decreasing the voltage in the grid. You have to pay penalty. Otherwise, you have to take corrective measures at your level to maintain the proper reactive power. That is, grid is allow you you can consume the reactive power within certain limit. ଆପଣ ସେମିତି କୌଣସି reactive devices use କରିବେନି ଯେ ବହୁତ reactive power reduce କରିବେ। ଯଦି ଆପଣ consume କରିବେ you have to take corrective measures at your level। ଆପଣ ଘରେ capacity ଲଗାନ୍ତୁ।
उपनी सर जो हमरो रिएक्टिव पावर सीरीज और पैरेलल लगने कौन सा बेनिफिट
the significance of the reactive power
That comes in transmission. In the transmission side, sending end and receiving end, in order to maintain the line voltage, what you are telling, series connection and parallel connection, that just the way it is UPQC, unified power flow condition, then we use that, we take care of both reducing the reactive power as well as increasing the reactive under no load. Say for example, power system when all loads are off, then receiving end voltage is higher than the sending end voltage. We have this phenomenon. It is called some effect. Yes, that case we need to reduce it. So we forcibly do.
of course
Yes, that is for transmission side we do.
out of certain load setting.
basically ଆପଣଙ୍କର
That also should not happen. Suddenly loads should not be removed also. Suddenly loads should not be increased also. That is why balance is required. Stable operation is very much important. So, sir, as you clarified, right, I noted is the range of delta. Now I got it. It is around 30 to 40 degrees. Yes, you are right. I told to 20. Sorry for that mistake.
11 ଯେତେବେଳେ ଆପଣ ଗେଟ୍ ଏକ୍ସାମିନେସନ ବା ପବ୍ଲିକ୍ ସେକ୍ଟର ଏକ୍ସାମିନେସନ
It is my preparation notes that I wrote it around 15 years ago.
ପିଲା ଯେମିତି ଏଇ ମାନେ ଯେମିତି ଏଇ ସବୁ ଭ୍ୟାଲୁ ଗୁଡାକୁ ମୋର କାରଣ ପୋଲିସ ପରୀକ୍ଷା କିମ୍ବା ଆପଣ ଗ୍ରାଜୁଏସନ ଆସିବ ପିଲା ଆସିବ ସେମିଷ୍ଟର ଏକ୍ସାମିନେସନ ଛାଡ଼ିଦେବ ଆସିବ ଏଇ ଯୋଉ ହାଇଲାଇଟେଡ୍ ପଏଣ୍ଟ ଗୁଡାକ ସେ ସେମାନେ ଯାଇକି ସବୁବେଳେ ରଖିଥିବେ ଯେଟାକି ଇଣ୍ଟରପ୍ରିଟେସନ କରିପାରିବେ ସେଇଟାକୁ ଆପଣ ହାଇଲାଇଟ୍ କରିବେ
ଏଠି କିଏ ଗୋଟେ ଆସିଲା
Okay. So we will go for lunch.
This is subject guest.
So we will meet at 2:30 p.m. Okay.
सर लंच पे कोई दिन लंच के लिए सर स्टॉप नहीं नहीं अभी अब फर्स्ट सेशन होगा